The universe never began. Let that sink in for a moment. The single most fundamental belief we hold about existence, that everything started with the Big Bang, might be our greatest cosmic misunderstanding. The Big Bang did not bang. There was no explosion, no divine moment of creation, no sudden birth of time from nothingness. What if, instead, we live within an infinite cosmic loop, a universe that breathes in endless cycles of expansion and contraction with no discernible beginning and no ultimate end? You've been told a story since childhood, a comforting tale about how approximately 13.8 billion years ago, everything, all matter, energy, space, and time itself, exploded into being from an infinitely dense, infinitely hot singularity. This narrative has become our cosmic creation myth, the scientific gospel that gives our existence a neat starting point, a comprehensible genesis. But what if this cherished origin story is merely a convenient fiction, a psychological crutch we've constructed because the alternative is too vast for our finite minds to comprehend? Consider this. When you look up at the night sky, gazing into that velvet darkness punctuated by distant stars, you aren't just looking outward into space. You're looking backward in time. Those photons traveling to your retina have journeyed across the cosmos for millions, even billions of years. They are messengers from the distant past, but how far back can we actually see? What lies beyond the cosmic horizon of our observation? What came before what we call the beginning? If you could somehow position yourself outside the universe, an impossible viewpoint, but imagine it nonetheless, and if you could rewind time like footage on an old film reel, what would you actually witness? Would you see everything collapsing toward an infinitesimal point? Or would you observe something profoundly more unsettling? A cosmic rhythm, a universe breathing out and in, expanding and contracting in an eternal dance that never truly began and will never truly end. The mathematics of our best cosmological models break down at the moment of the Big Bang. Physics, as we understand it, cannot describe what happens at this supposed T0 moment. This isn't just a minor inconvenience or a small gap in our knowledge. It's a gaping abyss at the foundation of our understanding of reality. And like all abysses, it both terrifies and beckons us to peer more deeply into its depths. What if the reason our equations fail isn't because of limitations in our mathematics, but because we're asking the wrong questions? What if the Big Bang wasn't the beginning at all, but merely a transition, one phase in an endless cosmic cycle? This isn't merely philosophical speculation. It's a possibility suggested by cutting-edge physics, loop quantum cosmology, cyclic models, conformal cyclic cosmology, theories that challenge the very foundation of our cosmic story. You might wonder why this matters. After all, whether the universe had a definite beginning or cycles eternally seems like an academic debate, with little relevance to your daily existence. But consider how profoundly our sense of cosmic history shapes our perception of ourselves. The linear narrative of the Big Bang gives our universe, and by extension, our lives, a distinct direction, an arrow of time that points from past to future, from beginning to eventual end. It places us somewhere along a cosmic timeline, creatures who exist for a brief moment in the universe's journey from birth to death. But a cyclic universe, a cosmos that loops back on itself endlessly, shatters this comforting linearity. It suggests a reality in which patterns repeat eternally, where nothing is truly new and nothing truly ends. In such a universe, are we unique creations, or are we inevitable recurrences, destined to appear and reappear in endless cosmic cycles? Have versions of you and I existed before, And will they exist again, infinitely? Does the concept of before even have meaning in a universe that loops like a Mobius strip? Imagine holding a snake that devours its own tail, the ancient symbol of the Ouroboros. Where does it begin? Where does it end? This image has haunted human consciousness across cultures and throughout history. Perhaps our ancestors intuited what our most sophisticated physics is only now suggesting, that reality might be circular rather than linear, cyclical rather than terminal. The stakes of this question extend beyond mere academic curiosity. If the universe cycles eternally, then entropy, the gradual degradation of energy that leads to what physicists call the heat death of the universe, may not be the final word. The universe may not be doomed to an eventual state of maximum disorder, where all stars have burned out, all black holes have evaporated, and all activity has ceased. Instead, this state of apparent death might itself be the prelude to another cycle of rebirth. Take a moment to truly visualize this possibility. Picture our expanding universe, galaxies racing away from each other into the darkness. Now imagine this expansion eventually slowing, stopping, reversing. Galaxies begin to approach one another. Once again, stars and planets collapse inward. Space itself contracts until everything, all matter and energy, reaches a state of incredible density and temperature. Not a singularity, perhaps, but a cosmic reset point, a moment of maximum compression before another expansion begins. This isn't science fiction. It's a serious cosmological model. Roger Penrose, the Nobel Prize-winning physicist, has proposed his conformal cyclic cosmology, suggesting that what we perceive as the Big Bang might actually be the result of the death of a previous universe. In this model, when a universe reaches its final state, when all black holes have evaporated and all particles have decayed, the distinction between the infinitely large and the infinitely small disappears. Without mass to define scale, the end of one universe becomes mathematically identical to the beginning of another. The implications are staggering. If Penrose is correct, then the apparent beginning of our universe, the Big Bang, was actually the transformed remnant of a previous universe's death. And our universe, when it eventually reaches its final state of maximum entropy, will itself transform into the Big Bang of the next cosmic cycle. Not creation from nothing, but transformation from everything. A perpetual cosmic metamorphosis. But why haven't we detected evidence of previous cycles? This is where the mystery deepens. Penrose suggests that we may have already observed the faint echoes of previous universes in the cosmic microwave background radiation, the eldest light in our cosmos, photons that have been traveling since 380,000 years after the Big Bang. He claims to have identified circular patterns in this radiation that could represent the remnants of supermassive black hole collisions from a previous cosmic cycle. These claims remain highly controversial. Most cosmologists remain unconvinced, but the mere possibility that we might detect the ghostly imprints of previous universes in our night sky is enough to send shivers down your spine. Imagine looking up at the stars and knowing that what you're seeing includes not just the history of our universe, but potentially the faint afterimage of a universe that came before. A cosmos that lived and died before our own was born. This cyclic vision transforms our understanding of cosmic time. In our conventional Big Bang narrative, time has a distinct beginning. Before the Big Bang, there was no before. Time itself did not exist. But in a cyclic model, time becomes more complex. Each cycle has its own temporal arrow, its own passage from order to disorder. But these cycles themselves may form a higher-order pattern that transcends what we typically understand as time. Think of it like the seasons on Earth. Within each year, we experience the linear progression from spring to winter. But zoom out far enough, and these linear segments form a cycle that repeats endlessly. Perhaps cosmic time works similarly, linear within each universal cycle, but cyclical when viewed from a higher perspective. This raises profound questions. Is there a cosmic meta-time that tracks the progression of these cycles? Or do the cycles themselves exist in a timeless state, an eternal return that transcends temporal concepts altogether? The ancient Greek philosophers pondered similar questions. Heraclitus observed that no man ever steps in the same river twice, for it's not the same river and he's not the same man. Yet the river itself, the pattern of water flowing between banks, persists despite this constant change. Perhaps our universe is like this river, constantly changing in its details but eternally persistent in its patterns. The specifics differ in each cycle, but the fundamental dance remains the same. This perspective challenges us to reconsider not just the beginning of our universe, but its ultimate fate. In the Standard Model, our cosmos faces a bleak future, the heat death, or big freeze, where all stars burn out, all black holes evaporate, and the universe becomes an ever-expanding, ever-cooling void of scattered particles too distant to interact. A cosmos not with a bang, but with a whimper. But if cyclical models are correct, this apparent death is merely a transition to something new, the winter that precedes another spring. Other cyclic models propose different mechanisms. Paul Steinhardt and Neil Turok's ekpyrotic universe suggests that our three-dimensional universe exists on a brane, short for membrane, in higher dimensional space. In this model, the Big Bang resulted from a collision between our brane and a parallel brane. These collisions happen repeatedly, with each one creating the conditions we associate with the Big Bang. Rather than a universe that expands and then contracts, they propose a universe that undergoes endless cycles of brane collisions, each creating the illusion of a new beginning. Loop quantum cosmology offers yet another perspective. This approach, stemming from loop quantum gravity, one of our most promising attempts to reconcile quantum mechanics with general relativity, suggests that space itself is not infinitely divisible, but is instead made up of discrete atoms of geometry. When the universe contracts to a certain minimum size, the repulsive effects of quantum gravity prevent further collapse, causing a bounce rather than a singularity. Our expansion phase may be just the latest in an infinite series of bounces, each representing a transition from contraction to expansion. These may sound like abstract theoretical frameworks, mathematical curiosities with little connection to observable reality. But that's not the case. Each of these models makes distinct predictions about the patterns we should observe in the cosmic microwave background radiation, the distribution of galaxies throughout space, and the nature of dark energy, the mysterious force accelerating our universe's expansion. As our observational tools become more sophisticated, we may find evidence that definitively favors one of these cyclic models over the traditional Big Bang narrative. What makes this possibility so captivating is not just its scientific significance, but its psychological and philosophical implications. We humans are storytelling creatures. We make sense of our lives through narratives with beginnings, middles, and ends. We mark time linearly: births, anniversaries, deaths. We conceptualize history as a forward progression. The idea of a universe without a true beginning or end, a reality that loops back on itself eternally, challenges the very structure of how we organize experience. In a truly cyclic universe, what happens to concepts like progress or purpose? If the cosmos endlessly repeats its patterns, are we trapped in a kind of cosmic Groundhog Day, doomed to relive variations of the same cosmic story without ever reaching a conclusion? Or does each cycle represent something new? A cosmic evolution where information or patterns might somehow persist from one cycle to the next, creating a kind of universal learning or growth across aeons. This question touches on the deepest philosophical puzzles of existence. Nietzsche's concept of eternal recurrence proposed a similar idea at the individual level. What if you were to live your exact life, with all its joys and sorrows, again and again for eternity? Would this be heaven or hell? Similarly, does a cyclical universe represent a kind of cosmic prison, the same patterns repeating without purpose? Or is it a kind of liberation from the tyranny of linear time and the dread of ultimate cosmic extinction? Consider another possibility. What if each cycle isn't an exact repetition? What if each cosmic rebirth represents a slightly different set of initial conditions, different physical constants, different fundamental forces? Then our universe might be just one iteration in an infinite cosmic experiment, with each cycle testing different parameters. In such a scenario, we exist in the particular cycle that happened to produce conditions favorable for life as we know it. An anthropic coincidence in an eternal cosmic laboratory. This vision resonates with certain religious and philosophical traditions. Hindu cosmology has long embraced the concept of cycles within cycles, from the small-scale yugas to the vast kalpas, representing the days and nights of Brahma, each lasting billions of years. In this tradition, our universe is just one breath, in an endless cosmic respiration. Buddhist cosmology similarly envisions worlds that form, exist, are destroyed, and lie dormant before forming again. These ancient intuitions about cosmic cycles find curious echoes in our most cutting-edge physics. But perhaps the most profound implication of a cyclic universe relates to the concept of information. In physics, information is never truly destroyed. It may be scrambled beyond practical recognition, but the fundamental patterns remain encoded somewhere in the cosmos. If our universe cycles eternally, what happens to this information? Does it somehow persist from one cycle to the next, creating a kind of cosmic memory that transcends the apparent reset of each new beginning? Some theorists have suggested that black holes might play a crucial role in this cosmic information transfer. These gravitational leviathans are information paradoxes in themselves. They appear to swallow information and make it inaccessible. Yet quantum mechanics insists this information cannot be truly lost. Perhaps black holes serve as the universe's hard drives, storing information in ways that might survive the transition from one cosmic cycle to the next. Imagine this possibility, that somewhere in the cosmic microwave background, radiation, or in the quantum fluctuations of empty space, there exist encoded patterns that represent the faint, scrambled memories of previous universal cycles. Might there be mathematical ghosts of previous civilizations, previous stars, previous galaxies, embedded in the very fabric of our reality? Might our universe unconsciously remember what came before? This brings us to a disturbing question. If the universe cycles eternally, and if each cycle contains the possibility of conscious life evolving, then conscious beings like ourselves have existed before and will exist again, infinitely. Not us exactly, perhaps, but beings similar to us, facing similar existential questions, gazing up at similar stars and wondering about similar cosmic mysteries. Are we, in some sense, cosmic recurrences rather than unique creations? The mathematician Hermann Weyl captured this unsettling possibility. The objective world simply is. It does not happen. Only to the gaze of my consciousness, crawling along the lifeline of my body, does a section of this world come to life as a fleeting image in space, which continuously changes in time. If this is true, if objective reality is a static, four-dimensional structure and our experience of flowing time is merely the result of our consciousness moving through it, then a cyclic universe implies something profoundly strange. It suggests that consciousness itself may be a recurring pattern, a natural emergence in any universe with the right physical laws, destined to rise again and again in endless cosmic cycles. This perspective transforms how we might think about the meaning of our existence. In a linear universe with a definite beginning and end, we might see ourselves as participating in a cosmic story that progresses toward some conclusion, whether it's heat-death, a big rip, where even atoms are torn apart by accelerating expansion, or some other definitive end. But in a cyclic universe, we are participants in an eternal cosmic dance, a pattern that repeats endlessly with infinite variations. Is this depressing or inspiring? Does it render our existence meaningless because it has happened before and will happen again? Or does it connect us to something greater, a timeless reality that transcends the apparent finitude of our individual lives? These questions have no definitive answers, but they reveal how profoundly our cosmic models shape our sense of meaning and purpose. Let's dive deeper into the physics that might make such a cyclic universe possible. Our current understanding suggests that the universe's fate depends largely on its geometry and the nature of dark energy, the mysterious force accelerating cosmic expansion. If dark energy remains constant or increases with time, the universe will expand forever, eventually becoming a cold, dark void. But if dark energy changes its behavior, if it weakens or reverses sign, expansion could eventually halt and reverse, leading to a big crunch that might seed another Big Bang. Recent observations have revealed that dark energy's behavior is more complex than we initially thought. Rather than remaining perfectly constant, it may have subtle variations over vast timescales. These variations might be too small to detect with current technologies, but over billions or trillions of years, they could dramatically alter the universe's trajectory. Perhaps what we're observing now, an accelerating expansion, is just one phase in a much longer cycle of expansion and contraction. Another possibility comes from string theory, which suggests our universe has extra dimensions beyond the three spatial dimensions we experience. These extra dimensions might be compactified, rolled up so tightly that we can't perceive them, but they could still influence cosmic evolution. Some string theorists propose that these hidden dimensions undergo their own cycles of expansion and contraction, potentially driving the rhythms of our observable universe. The challenge for all these cyclic models is entropy, the inexorable increase in disorder that the second law of thermodynamics demands. Each cosmic cycle should be more disordered than the last, which would create observable differences between cycles. Yet if the universe truly repeats, these differences should be reset somehow. Various theoretical mechanisms have been proposed to reset entropy between cycles, but none have gained universal acceptance among physicists. Penrose's conformal cyclic cosmology addresses this by suggesting that when all matter has decayed and all black holes have evaporated, a process that would take an unimaginably long time, the universe reaches a state where there's no mass to define scale. Without mass, there's no way to distinguish between the infinitely large and the infinitely small. In this condition, the end of one universe becomes mathematically identical to the beginning of another, effectively resetting entropy. This is profoundly counterintuitive. It suggests that the incredibly dispersed, low-density state of a universe at maximum entropy is somehow equivalent to the incredibly dense, high-energy state we associate with the Big Bang. It's as if the cosmic endgame loops back to become a new opening move, like a video game that seamlessly transitions from the final level back to the first, without any loading screen. The evidence for these cyclic models remains tentative. Penrose and his colleagues claim to have identified concentric circles in the cosmic microwave background that might represent the echoes of supermassive black hole collisions from a previous cosmic cycle. Other researchers dispute these findings, suggesting they may be statistical flukes or observational artifacts rather than genuine cosmic signals. Steinhardt and Turok's ekpyrotic model, meanwhile, predicts subtle patterns in how galaxies are distributed throughout space, patterns that differ from those predicted by conventional Big Bang inflation. As our maps of the cosmos become more detailed, we may find evidence that favors one model over the other. Loop quantum cosmology makes its own predictions, particularly about gravitational waves, ripples in space-time that were first directly detected in 2015. If the universe underwent a quantum bounce rather than emerging from a true singularity, it should have produced a distinctive spectrum of primordial gravitational waves that future detectors might identify. What makes this scientific quest so fascinating is that we're using the universe itself as our laboratory, attempting to decipher its history and future by carefully observing the clues it has left for us. We are cosmic detectives, piecing together the ultimate cold case, the origin and fate of everything that exists. But even as we gather more data and refine our theories, we should recognize the profound limitations of our perspective. We are tiny beings on a small planet, orbiting an ordinary star in one galaxy among billions. Our lives last for mere decades in a universe that operates on timescales of billions or trillions of years. Our brains evolved to hunt on savannas and live in small social groups, not to intuitively grasp quantum mechanics or cosmic evolution. Given these limitations, it's remarkable that we've pieced together as much as we have about cosmic history, but we should maintain epistemic humility, an awareness that our current models, however sophisticated, are likely approximations at best, crude sketches at worst. The true nature of reality may be far stranger than even our most audacious theories suggest. This brings us back to our opening provocation. The universe never began. This statement is not merely contrarian. It reflects a serious possibility in contemporary cosmology. If any of these cyclic models prove correct, then what we call the Big Bang was not the absolute beginning of everything, but merely a transition point. One moment in an eternal cosmic process that has no first day and will have no final night. Such a revelation would require us to fundamentally reimagine our place in cosmic history. Rather than being relatively early inhabitants of a universe with a definite beginning and end, we would be participants in an ageless cycle, one iteration of a pattern that repeats eternally. Our atoms would have been recycled through countless cosmic deaths and rebirths, taking on infinite configurations throughout an endless cosmic evolution. This perspective echoes what the astronomer Carl Sagan famously observed. We are a way for the cosmos to know itself. If the universe cycles eternally, then it has been knowing itself through conscious beings like us for eternity, and will continue to do so forever. Consciousness may be not an accident or a side effect, but an inevitable emergence in a universe that provides the right conditions, conditions that have appeared before and will appear again in endless cosmic cycles. But what would it mean for our scientific understanding if we confirmed that the universe is indeed cyclical? It would resolve certain theoretical problems with the Big Bang model, particularly the question of what came before, and why the initial conditions were precisely what they were. In a cyclic universe, there is no ultimate before, no need for initial conditions to be set by some external factor. The conditions at the beginning of each cycle emerge naturally from the conditions at the end of the previous one. This would also transform our understanding of time itself. Rather than being an absolute dimension that stretches indefinitely backward and forward, time might be more like a circle, where traveling far enough in one direction eventually brings you back to your starting point. Or perhaps time as we experience it is merely an emergent property of each cycle, with something more fundamental connecting one cycle to the next. The poet T.S. Eliot captured this circular vision of time in the opening of his 4 quartets. Time present and time past are both perhaps present in time future, and time future contained in time past. If all time is eternally present, all time is unredeemable. This poetic insight resonates with what our most advanced physics now suggests, that the neat division of time into past, present, and future may be more a limitation of our perspective than a fundamental truth about reality. Just as we now understand that the apparent solidity of matter is an illusion concealing the quantum dance of particles, perhaps the apparent linearity of time conceals a deeper circular structure that we're only beginning to comprehend. But let's return to the evidence. What would definitively prove or disprove these cyclic models? Astronomers are developing increasingly sensitive instruments to map the cosmic microwave background radiation in unprecedented detail. The patterns in this ancient light contain clues about the universe's earliest moments. If our universe emerged from a quantum bounce or a brane collision rather than a true singularity, the statistical properties of these patterns should differ, in subtle but detectable ways, from what the conventional Big Bang model predicts. Similarly, as our understanding of dark energy improves, we might detect slight variations in its strength over time, variations that could indicate whether the IDF universe's expansion will continue accelerating forever or eventually reverse. The Dark Energy Spectroscopic Instrument, DESI, and upcoming projects like the Euclid Space Telescope and the Vera C. Rubin Observatory are designed to measure dark energy with unprecedented precision, potentially revealing clues about the universe's ultimate fate. Gravitational wave astronomy, a field that barely existed a decade ago, offers another avenue for investigation. Future gravitational wave observatories, both on Earth and in space, will be able to detect the faint ripples in Nahi, space-time left over from the universe's earliest moments. These primordial gravitational waves would carry distinct signatures depending on whether the universe began with a singularity, a quantum bounce, or a brane collision. But perhaps the most tantalizing possibility is that we might detect direct evidence of previous cosmic cycles. Penrose's identification of concentric rings in the cosmic microwave background, if confirmed, would represent exactly this kind of evidence. The faint echoes of supermassive black hole collisions from a previous cosmic incarnation, somehow preserved through the transition from one cycle to the next. Imagine the profound moment of discovery if these findings were definitively confirmed. If we knew with certainty that our universe was not the first and would not be the last, that we exist within one heartbeat of an eternal cosmic pulse, it would represent a revolution in our understanding comparable to the Copernican realization that Earth is not the center of the universe, or the Darwinian insight that humans are one branch on a vast evolutionary tree. Yet even without definitive proof, these cyclic models invite us to expand our cosmic imagination, to consider possibilities that transcend our intuitive understanding of time and causality. They remind us that our most cherished scientific narratives, including the Big Bang Theory, are not final truths, but working models, sophisticated approximations of a reality that may be far stranger than we can currently conceive. This is the essence of scientific progress, not the accumulation of final answers, but the continuous refinement of our questions. Each generation of scientists pushes the boundaries of knowledge further, revealing new mysteries in the process. The quest to understand whether the universe is linear or cyclical is part of this grand scientific journey. A journey that has no endpoint because each discovery reveals new horizons to explore. For you, gazing up at the night sky, this cosmic question may seem distant from daily concerns. But consider how profoundly our cosmic narratives shape our sense of meaning and purpose. The linear Big Bang story suggests we exist at a particular moment in cosmic history, with a definite past behind us and a definite future ahead. A cyclic model suggests something different, that we participate in an eternal pattern, a cosmic rhythm that has no beginning and no end. Neither perspective definitively answers the deepest why questions about existence, but both remind us of the privilege of consciousness, the remarkable fact that in a universe of stars and galaxies, planets and black holes, there exist creatures capable of contemplating their own origins and the nature of reality itself. Whether our universe had a definite beginning or cycles eternally, the fact that it has produced beings capable of asking these questions remains one of the greatest wonders of existence. As we stand at this frontier of understanding, poised between competing cosmic narratives, we should embrace both the knowledge we've gained and the mysteries that remain. The universe began with the Big Bang. Or perhaps it didn't. Perhaps it never truly began at all, but has always existed in an eternal cycle of death and rebirth. This uncertainty is not a failure of science, but its greatest strength, the humble acknowledgement that reality may be far vaster and stranger than our current theories suggest. So the next time you look up at the stars, consider this possibility. You may be gazing not just at the aftermath of a singular cosmic beginning, but at one frame in an eternal cosmic film that loops without end. Those distant lights may have shone before and may shine again in endless cosmic cycles. And beings like you may have wondered at these same mysteries before, and may wonder again, eternally puzzling over the greatest question of all, whether the universe had a beginning, or whether it simply is, was, and always will be, a loop with no end. For nearly a century, we've lived with a comforting certainty. The universe is expanding. This truth has been our cosmic cornerstone, the foundation upon which modern cosmology stands. In 1929, Edwin Hubble observed that distant galaxies are moving away from us, and the farther they are, the faster they recede, as if the fabric of space itself is being stretched in all directions. This observation gave birth to the expanding universe model, a concept so fundamental to our understanding of reality that it has shaped how we conceptualize our very existence. But expansion implies a beginning, a moment when everything was infinitely close together. And so was born the concept we now call the Big Bang, a term ironically coined by Fred Hoyle, one of its greatest critics. This model has become more than science. It's become our shared cosmic origin story, a creation myth dressed in equations and observational data. Picture it, a universe compressed into a volume smaller than a proton, denser than a trillion neutron stars, hotter than any temperature our mathematics can meaningfully describe. Not just matter and energy squeezed to impossible density, but space and time themselves twisted into configurations our minds cannot visualize and our equations cannot fully resolve. This is not just the beginning of stars and galaxies. It is the beginning of physics, the moment when the rules of reality as we understand them took shape. Or is it? The Big Bang Theory has been spectacularly successful, predicting phenomena that we've later observed with remarkable precision. The cosmic microwave background radiation, the faint afterglow of creation still permeating all of space, the precise abundances of hydrogen, helium, and lithium in the early universe, the large-scale structure of galactic superclusters stretching across billions of light-years. These predictions turned observations have cemented the Big Bang as the dominant paradigm in cosmology. And yet, there are whispers in the data, anomalies at the edges of our observations, mathematical inconsistencies that won't quite resolve, no matter how we manipulate our equations. These whispers have grown louder in recent years, suggesting that perhaps, just perhaps, the universe has a deeper story to tell, one that extends beyond the apparent beginning we call the Big Bang. To understand these whispers, we need to journey together through the cosmos as we currently understand it, exploring not just what we know, but the boundary between knowledge and mystery, the frontier where our most sophisticated theories begin to fray at the edges. The universe we observe today is vast beyond comprehension, 93 billion light-years in diameter, containing hundreds of billions of galaxies, each home to hundreds of billions of stars. And it's getting bigger. Space itself expands at every point, stretching like an infinite balloon being inflated from within. Galaxies aren't moving through space so much as being carried apart by space's expansion. But this expansion isn't uniform throughout cosmic history. For the first 300,000 years after the Big Bang, the universe was opaque, a seething plasma so dense and hot that light could not travel freely. The entire cosmos roared with energy as photons endlessly bounced between electrons in a luminous fog that would have blinded any hypothetical observer. This was no gentle glow, but an all-encompassing inferno where the distinction between matter and energy blurred, where the very forces of nature were still sorting themselves out from the primordial unity. As the universe expanded, it cooled, allowing electrons to bind with protons to form the first atoms, primarily hydrogen with a sprinkling of helium. Suddenly, photons could travel freely through space. This moment, the release of what we now detect as the cosmic microwave, background radiation, represents our earliest direct observation of the universe. We cannot see past this cosmic dawn. It forms the limit of our electromagnetic vision. But the story continues backward. Before this moment of transparency, the ADE universe experienced an even more dramatic phase, a period of exponential expansion called cosmic inflation. In an unimaginably brief instant, about 10^32 seconds, the universe expanded faster than the speed of light, growing from a subatomic speck to astronomical scales. This wasn't matter moving through space. It was space itself expanding at a rate that defies our intuitive understanding of physics. Inflation explains several cosmic puzzles: why the universe appears flat rather than curved, why temperature variations in the cosmic microwave background are so remarkably uniform across vast distances that could never have been in causal contact, and why we don't observe magnetic monopoles that should have been produced in the early universe. But inflation raises as many questions as it answers. What sparked this brief but critical period of hyperexpansion? What mechanism halted it, allowing the universe to transition to the more sedate expansion we observe today? And if inflation stretched space so dramatically, what came before? Was there a pre-inflationary phase with different physical laws, different dimensions, different concepts of time? Here we begin to probe the earliest moments after the supposed Big Bang, the Planck epoch, occurring in the first 10.43 seconds of cosmic history. During this unimaginably brief period, all four fundamental forces, gravity, electromagnetism, and the strong and weak nuclear forces, may have been unified in a single superforce. The temperature would have been approximately 10 to the 32 degrees Kelvin, energies so extreme that concepts like space and time as we understand them lose their conventional meaning. This is physics at its most speculative frontier, where Einstein's general relativity, our best theory of gravity and spacetime, collides with quantum mechanics, which governs the subatomic realm. These two pillars of modern physics, each breathtakingly successful in its domain, have resisted unification for nearly a century. Their mathematical languages seem fundamentally incompatible, leaving us without a complete framework to describe the universe's earliest moments. Imagine the early universe not as a point of infinite density, a mathematical impossibility that signals the breakdown of our theories, but as a quantum foam, a roiling sea of space-time where dimensions fluctuate. Particles pop in and out of existence, and the arrow of time hasn't yet found its direction. This isn't just abstraction. It represents genuine attempts by physicists to reconcile gravity with quantum mechanics, to peer behind the veil of the Big Bang. String theory suggests that the fundamental building blocks of reality aren't particles, but tiny vibrating strings of energy whose oscillation patterns determine the properties of the particles we observe. This elegant framework requires extra spatial dimensions beyond the three we experience, dimensions curled up so tightly that they remain invisible to us, yet profoundly influence the cosmos's evolution. In some string theory scenarios, our universe might be a four-dimensional brain floating in a higher dimensional bulk, occasionally colliding with other brains in cosmic events that could manifest as Big Bang-like beginnings. Loop quantum. Gravity, meanwhile, proposes that space itself isn't infinitely divisible but composed of discrete units, atoms of geometry with a minimum possible size. In this framework, the Big Bang singularity gets replaced by a big bounce, a moment of maximum compression where quantum gravitational effects cause repulsion, transitioning a contracting universe into an expanding one. These aren't just abstract, mathematical constructs. They represent genuine attempts to understand what happened at the beginning, or if there even was a beginning. They challenge us to reconsider not just our cosmic history, but the nature of reality itself. Now, take a moment to truly visualize the universe as it exists today, expanding outward from that ancient moment of incredible density. Galaxies hurtle away from each other into the darkness, each one a vast island of stars, hundreds of billions, of suns, many with their own planetary systems, possibly harboring life forms contemplating their own existential questions. Between these galactic islands lies mostly emptiness. Vast cosmic voids, hundreds of millions of light-years across, containing only the faintest wisp of hydrogen gas. This expansion is accelerating. Dark energy, a mysterious pressure that permeates empty space, pushes the universe to expand faster as time progresses. If this acceleration continues, the cosmos faces a big freeze, or heat death. Eventually, stars will exhaust their nuclear fuel. Galaxies will grow so distant from each other, they'll disappear from view, and even black holes will evaporate through Hawking radiation. The universe will approach maximum entropy, a state of perfect disorder where no work can be done, no information processed, no life sustained. But this presumes the continuation of current conditions. What if dark energy's behavior changes over time? What if the vacuum of space isn't stable, but exists in a temporary state that could decay to a lower energy configuration? What if gravity behaves differently at the largest scales than our current models predict? These aren't idle speculations. Observational cosmologists have detected potential anomalies in the cosmic microwave background, patterns that don't quite match what our standard models predict. The distribution of galaxies shows subtle structures that hint at forces or phenomena not accounted for in our current theories. And perhaps most mysterious of all, the expansion rate of the universe measured through different methods yields slightly different values, a discrepancy known as the Hubble tension that has persisted despite years of refined measurements. Could these anomalies be telling us something profound about the nature of the cosmos? Might they be clues that our universe doesn't simply expand from a beginning to an end, but participates in a greater cosmic cycle? Consider again the fate of an expanding universe dominated by dark energy. Galaxies recede from each other at an ever-increasing rate until they disappear beyond each other's cosmic horizons. Stars die. Matter decays. After unimaginable aeons, literally trillions upon trillions of years, all that remains are scattered elementary particles and radiation, too distant from each other to interact, too cold to fuel any process we would recognize as physics. The universe approaches what physicists call heat death, a state of maximum entropy, perfect disorder, where nothing happens and nothing can happen. Time becomes meaningless when change becomes impossible. The cosmos becomes a frozen waste, expanding eternally into darkness. But what if this isn't the end? What if, in some profound way we're only beginning to understand, this apparent end connects back to another beginning? Roger Penrose's conformal cyclic cosmology proposes exactly this. In the far future, when all matter has decayed and all black holes have evaporated, the universe reaches a state with no masses to measure distance against. Without mass, the distinction between the infinitely large and the infinitely small vanishes. The end state of one universe becomes mathematically equivalent to the beginning of another. The circle closes. A new cycle begins. This isn't mere speculation. Penrose points to potential evidence in the cosmic microwave background. Concentric rings that might represent the echoes of supermassive black hole mergers from a previous cosmic cycle. Their gravitational waves transformed into temperature variations in our universe's earliest light. Or consider the ekparodic scenario proposed by Paul Steinhardt and Neil Turok. Perhaps our universe exists as a three-dimensional membrane or brain in a higher dimensional space. The Big Bang might represent a collision between our brain and another, a cosmic traffic accident that releases enough energy to seed a new universe. These collisions could happen repeatedly, creating an endless sequence of Big Bangs, each initiating a new cycle of cosmic evolution. Loop quantum cosmology suggests yet another mechanism. As a contracting universe approaches what classical physics would describe as a singularity, quantum gravitational effects create an enormous pressure that causes a bounce rather than a complete collapse. Like a cosmic spring compressed to its limit, the universe rebounds into a new expansion phase. Our Big Bang might be merely the latest in an infinite series of bounces, extending infinitely backward and forward in time. These competing models make different predictions about the properties we should observe in our universe today. The specific patterns in the cosmic microwave background, the distribution of galaxies throughout space, the behavior of gravity at the largest scales, each provides potential evidence that might favor one cyclic scenario over another, or over the standard Big Bang cosmology. What makes this quest so compelling isn't just scientific curiosity. It touches on the deepest questions of existence. Are we living in the only universe that has ever existed, or one incarnation among countless others? Does time flow in one direction toward an ultimate end, or does it somehow loop back on itself? In a grand cosmic cycle? Is our existence a unique event in cosmic history, or part of an eternal pattern that repeats with endless variations? The stakes of these questions extend beyond astronomy. They shape how we conceptualize our place in the cosmos, our relationship to time, our understanding of creation and destruction. They influence our metaphysics, our most fundamental ideas about reality itself. But to truly explore these possibilities, we need to examine some apparent contradictions in our current understanding, puzzles that might be resolved by adopting a cyclic perspective. Consider the entropy problem. According to the second law of thermodynamics, entropy, a measure of disorder, always increases in a closed system. Each cosmic cycle should be more disordered than the last. Yet if the universe cycles eternally, these differences would accumulate, creating observable consequences. The fact that our universe began in a remarkably low entropy state, a highly ordered configuration that has been increasing in disorder ever since, presents a challenge for cyclic models. How can a universe reset its entropy between cycles? Various mechanisms have been proposed. In conformal cyclic cosmology, the complete decay of all particles and the evaporation of all black holes creates a state where entropy becomes undefined, a clean slate for the next cycle. In brane cosmology, the entropy of one cycle gets redistributed into the extra dimensions, cleansing our three-dimensional space for the next round. Loop quantum cosmology suggests quantum gravitational effects might effectively forget entropy information during the bounce phase. None of these solutions has gained universal acceptance, but they illustrate the theoretical ingenuity being applied to reconcile cyclic cosmologies with thermodynamic laws. Another puzzle concerns the asymmetry of time. We experience time as flowing inexorably from past to future, never backward. Physical processes have a clear temporal direction. Eggs break but don't unbreak. Coffee cools but doesn't spontaneously heat up. People age rather than growing younger. This arrow of time aligns with entropy's increase. Systems naturally evolve toward more disordered states. In a cyclic universe, what happens to time's arrow? Does it reverse during contraction phases? Does each cycle have its own temporal direction? Or is there some deeper principle that maintains time's asymmetry across cosmic cycles? These questions remain open, with different cyclic models offering different perspectives. Perhaps most puzzling is the fine-tuning problem. Our universe appears exquisitely calibrated for complexity and, ultimately, life. If fundamental constants like the strength of gravity or the electron's charge were slightly different, stars couldn't form, chemistry couldn't function, and life as we know it would be impossible. This apparent fine-tuning has led some to invoke the anthropic principle, the idea that we observe a life-permitting universe precisely because we could only exist in such a universe to observe it, or even to suggest divine design. Cyclic models offer another perspective. If the universe has undergone countless cycles, each with slightly different physical parameters, then we naturally find ourselves in one of the rare cycles that happens to permit our existence. No designer is required. Given enough cosmic rolls of the dice, eventually a life-permitting universe emerges through chance alone. This multiverse concept, the idea that our universe represents just one possibility among many, appears in various forms across contemporary cosmology. Inflation naturally generates an infinite landscape of bubble universes, each with potentially different physical laws. String theory suggests a vast landscape of possible vacuum states, different configurations of those extra curled-up dimensions, each creating universes with different physical constants. Cyclic models propose an endless sequence of universal incarnations, potentially exploring different physical parameters with each rebirth. In all these scenarios, our universe isn't unique, but one manifestation of a much vaster reality. This perspective transforms how we think about cosmic fine-tuning, offering a naturalistic explanation for our universe's apparent design without requiring a designer. But there's another puzzle, perhaps the most fundamental of all. Why is there something rather than nothing? Why does the universe exist at all? This question has haunted philosophers and theologians for millennia, and no scientific theory can fully resolve it. Even if we understand how the current universe emerged from a Big Bang, why was there a Big Bang rather than absolute nothingness? Cyclic cosmologies don't ultimately answer this question. They push it back to a more fundamental level. Instead of asking why this universe exists, we must ask why the cycle exists. But they do offer a different perspective on the concept of creation. Rather than a universe that appears mysteriously from nothing, they present a cosmos that transforms endlessly from one state to another, with no absolute beginning and no final end. This vision resonates with certain religious and philosophical traditions, particularly Eastern concepts like the Hindu notion of endless cosmic cycles, or the Buddhist concept of samsara, the wheel of existence. Where Western religious traditions often emphasize linear time with a definite creation and eventual conclusion, Eastern perspectives have long embraced cyclical concepts of time and existence. The parallels aren't exact, of course. Modern scientific cosmologies operate in a materialist framework, without references to deities or spiritual forces. But the resonance between ancient intuitions and cutting-edge physics suggests that the concept of cosmic cycles touches something deep in human thought, perhaps an intuitive recognition that emergence and dissolution, creation and destruction are complementary aspects of a greater process, rather than absolute beginnings and endings. Now, let's visualize more concretely what a cyclic universe might look like, focusing on the details of different models. In conformal, cyclic cosmology, our present expanding universe continues accelerating, driven by dark energy. Over unimaginable timescales, trillions upon trillions of years, all stars burn out, all black holes evaporate through Hawking radiation, and even protons decay into pure radiation. The universe becomes an ever-expanding sea of photons, gravitons, and neutrinos, massless particles traveling eternally through emptiness. But in this model, something remarkable happens. Without massive particles to establish a scale, the distinction between infinitely large and infinitely small vanishes. Mathematically, this universe becomes equivalent to a new Big Bang, not through a contraction phase, but through a conformal transformation that maps the infinite future of one cycle onto the infinitesimal beginning of the next. This transformation preserves angles but not distances, allowing the endless expansion of one cycle to become the explosive beginning of another. From our perspective within a single cycle, we observe a universe with a beginning and an apparent end. But from a higher vantage point, one that transcends the limitations of a single cycle, the cosmos reveals itself as an eternal sequence, each cycle emerging seamlessly from the transformed remnants of the previous one. In the ekpyrotic scenario, our universe exists as a three-dimensional membrane floating in a higher dimensional space. Occasionally, our membrane collides with another. These collisions aren't haphazard, but occur in a choreographed dance driven by attractive forces between the brains. When the brains collide, their kinetic energy converts into matter and radiation, creating what we perceive as a Big Bang. The brains then separate, pulling apart as our universe expands. Eventually, the attractive forces between them overcome the separation, drawing them back together for another collision. Each collision creates a new beginning, a new apparent Big Bang, without requiring the universe to contract or recollapse. The cycles occur not within our three-dimensional space, but through movement in the extra dimensions. This model potentially resolves several puzzles in standard Big Bang cosmology. It doesn't require inflation to explain the universe's homogeneity or flatness. These properties emerge naturally from the dynamics of brain collisions. It also provides a natural explanation for dark energy as a manifestation of the force between brains. Most intriguingly, it suggests that what we perceive as the beginning of time might actually be a transition point, a dramatic but not absolute beginning. Loop quantum cosmology offers yet another vision of cosmic cycles. As the universe contracts toward what classical physics would describe as a singularity, quantum gravitational effects become dominant. Space can't be compressed beyond a certain minimum size, the Planck length, about 10⁻⁻⁵ to 35 meters. When the universe approaches this limit, quantum gravity generates a repulsive force that causes a bounce, rather than a complete collapse. This quantum bounce would be brief but extraordinary, a moment when the entire universe transitions from contraction to expansion, from growing denser to growing more diffuse. It would represent neither a beginning nor an end, but a turning point, a cosmic reversal that connects one phase of universal evolution to another. The bounce itself would be unlike anything we can directly visualize. Traditional concepts of space and time break down at this scale, replaced by quantum probabilities and non-classical geometries. But mathematical models suggest the process would be smooth rather than singular, a continuous evolution from contraction to expansion, with no undefined mathematical points where physics simply fails. This model makes specific predictions about what we should observe today. The bounce would leave subtle imprints in the cosmic microwave background, specific patterns of temperature variations that differ from those predicted by standard inflationary models. It would also generate primordial gravitational waves with characteristic frequencies and amplitudes that future detectors might identify. All these cyclic scenarios face significant challenges. They must explain why we observe a universe that appears to have a definite beginning. They must account for the remarkably low entropy of the early universe. They must provide mechanisms that allow cycles to continue eternally without degrading. Due to the second law of thermodynamics, none has achieved consensus among physicists. Each represents a speculative frontier rather than established science. But this speculation isn't idle fantasy. It's the cutting edge of theoretical physics, driven by genuine puzzles in our current understanding and subject to rigorous mathematical consistency and eventual observational testing. What makes these models particularly compelling is that they don't merely tweak existing theories. They fundamentally reimagine cosmic history. They suggest that what we've long considered the ultimate beginning, the Big Bang, might actually be a transition point in a much grander cosmic process. They transform our universe from a one-time event with a definite beginning and eventual end into one chapter in an endless cosmic story. This perspective alters how we think about time itself. Instead of a linear arrow pointing inexorably from past to future, time might be better conceptualized as a spiral, moving forward within each cycle but returning to similar states in the grand pattern of cycles. Or perhaps there exists a higher-order meta-time that tracks the progression of cycles, while each cycle has its own internal temporal direction. These concepts strain our mental frameworks. We're evolved to think in terms of beginnings and endings, causes and effects arranged in linear sequences. Our languages embed these assumptions in their very grammar. To truly grasp a cyclical cosmos requires stretching our cognitive capacities beyond their evolved limitations, perhaps even developing new conceptual tools and metaphors. Consider this analogy. The surface of a sphere has no edge, no boundary, no beginning or end point, yet it's finite in area. A two-dimensional being living on the sphere's surface could travel indefinitely in any direction without ever reaching a border. Similarly, a cyclic universe has no temporal boundary, no absolute beginning or end, yet each cycle has finite duration. Cosmic time might loop back on itself like the sphere's surface, with no privileged moment that could be identified as the ultimate beginning. Or imagine the cyclical nature of Earth's seasons. From within the system, we experience a linear progression, from spring to winter. But viewed from outside, this apparent linearity reveals itself as part of a greater cycle, repeating with endless variations year after year. Our cosmic history might function similarly, apparently linear when viewed from within a single cycle, but cyclical when seen from a broader perspective. These analogies are imperfect, of course. The universe's cyclic nature, if it exists, operates on scales and dimensions beyond our direct experience. But they provide conceptual handholds for grappling with ideas that challenge our intuitive understanding of reality. The possibility of a cyclical cosmos also transforms our perspective on existence itself. If the universe cycles eternally, then matter and energy are never truly created or destroyed. They merely transform from one state to another in an endless cosmic dance. The atoms in your body have been recycled through countless cycles, taking part in the death and rebirth of universes, perhaps arranging themselves into structures of comparable complexity in previous cosmic incarnations. This isn't mere poetic license. It's a genuine implication of certain cyclic models. If information in some form persists between cycles, if patterns or structures from one cycle influence the next, then the cosmos possesses a kind of memory that transcends any single, universal incarnation. The universe might learn from its own history, developing patterns and complexities that build upon previous cycles rather than starting fresh each time. Some theorists have even speculated about the potential for conscious beings in one cycle to influence subsequent cycles, perhaps by encoding information in structures that might survive the transition, or by manipulating cosmological parameters in ways that echo through later universal incarnations. While highly speculative, such possibilities illustrate how profoundly cyclical models could reshape our understanding of cosmic purpose and meaning. But let's return to more concrete scientific ground. How might we determine whether our universe is truly cyclical? What evidence would definitively distinguish between linear and cyclical cosmologies? One approach involves the cosmic microwave background radiation, the oldest light in our universe, released when the cosmos became transparent about 380,000 years after the Big Bang. This ancient radiation has been traveling through space for 13.8 billion years, and it carries imprints of the universe's earliest moments. Penrose claims to have identified concentric rings of unusually consistent temperature in this radiation, patterns he interprets as the transformed remnants of gravitational waves generated by black hole mergers in a previous cosmic cycle. Other researchers dispute this finding, suggesting it may be a statistical fluke rather than genuine evidence. As our observations become more precise, we may be able to confirm or refute such patterns with greater confidence. Another avenue involves gravitational waves, ripples in spacetime generated by violent cosmic events. Future gravitational wave. Observatories will be sensitive enough to detect primordial gravitational waves from the universe's earliest moments. Different cosmological models predict different spectra for these waves. Cyclic models, particularly those involving a bounce rather than a singularity, predict specific patterns that could be distinguished from those of conventional Big Bang models. Dark energy provides yet another test. If dark energy's strength varies over time, rather than remaining constant, it could eventually weaken or reverse sign, causing the universe's expansion to slow and potentially reverse. Precise measurements of how cosmic expansion has evolved over billions of years might reveal subtle variations that point toward an eventually recollapsing universe, one phase of a greater cycle. The distribution of galaxies throughout space, the cosmic web of filaments, sheets, and voids that forms the universe's large-scale structure also contains clues. Different cosmological models predict slightly different statistical patterns in how galaxies cluster. As our three-dimensional maps of the cosmos become more comprehensive and detailed, they may favor one model over others. But perhaps the most fascinating possibility is that we might detect direct evidence of previous cycles, faint imprints left in our universe's structure by its cosmic predecessors. These might take the form of statistical anomalies in the distribution of matter and energy, patterns that can't be explained by processes within our current cosmic incarnation, but make sense as echoes from a previous cycle. Such evidence remains tentative at best. Most cosmologists still favor the standard Big Bang model, with its linear progression from a singular beginning toward an eventual heat death. But the very fact that serious scientists are exploring cyclical alternatives, developing sophisticated mathematical models, and proposing observational tests indicates how the field has evolved beyond the simple narrative of a universe that begins once and ends once. This evolution reflects a broader pattern in the history of cosmology. Each time we've believed we've reached a comprehensive understanding of the cosmos, new observations and theoretical insights have revealed deeper layers of reality. The Earth-centered universe gave way to the heliocentric model. The concept of a static universe yielded to the expanding cosmos. The idea of a universe dominated by ordinary matter has been superseded by dark matter and dark energy. Perhaps the notion of a universe with an absolute beginning will similarly be refined into a more nuanced understanding of cosmic cycles. The quest to determine whether the universe is linear or cyclical isn't merely academic. It touches on profound questions about our place in the cosmic scheme. Are we participants in a unique cosmic story with a definite beginning and end? Or are we one manifestation of a pattern that repeats with endless variations, a brief arrangement of atoms and energy in an eternal cosmic process? Neither answer fully resolves the mystery of existence. Even if the universe cycles eternally, we can still ask why cycles exist at all, rather than absolute nothingness. But a cyclical perspective does transform how we conceptualize our relationship to time, to beginning and ending, to creation and destruction. It suggests that these apparent opposites might be complementary phases of a greater process rather than absolute states. This brings us back to our opening question. Does the universe have an edge, a boundary, a beginning? If it cycles eternally, then what we've called the Big Bang wasn't the absolute beginning, but a transition point. One moment in an endless cosmic process. The universe would have no temporal edge, no first moment, no ultimate origin, just as a circle has no beginning point and no end point. But this apparent simplicity conceals profound complexity. Each cycle would differ from the previous ones in its details. The precise distribution of matter and energy, the locations of stars and galaxies, the emergence of life and consciousness. The pattern repeats, but the specifics vary endlessly. The cosmos plays the same symphony over and over, but with unique improvisations each time. If this cyclic vision proves correct, it would represent a revolution in our cosmic understanding comparable to the Copernican realization that Earth isn't the center of the universe. Just as Copernicus showed that our planet occupies no privileged position in space, cyclic cosmologies suggest that our era occupies no privileged position in time. Our universe would be neither the first nor the last, but one incarnation in an infinite sequence. This perspective doesn't diminish our significance. It connects us to something vaster. If the universe cycles eternally, then the atoms in your body have participated in countless cosmic deaths and rebirths. The hydrogen in your cells was forged in the Big Bang, not as a one-time event, but as one phase in an endless cosmic process. You aren't just stardust, you're the debris of multiple universes, recycled through infinite cosmic cycles. And if consciousness is an emergent property of sufficiently complex arrangements of matter, if it arises naturally given the right conditions, then awareness like yours has emerged before and will emerge again, infinitely. Not you specifically, but consciousness with similar questions, similar wonder, similar appreciation for the cosmos that gave it birth. This connection to cosmic cycles appears in many ancient philosophical and religious traditions. The Hindu concept of kalpas envisions cosmic creation and destruction as the breath of Brahma, inhaling and exhaling universes across timescales of billions of years. Buddhist cosmology describes worlds that form, exist, are destroyed, and lie dormant before forming again. Ancient Greek philosophers like Heraclitus and Empedocles conceptualized reality as an eternal cycle of elements combining and separating, coming together and falling apart. These intuitions that becoming and dissolution, creation and destruction are complementary aspects of a greater process, find curious resonance in our most advanced physics. They remind us that the cyclic perspective isn't merely a recent theoretical development, but a recurring insight in human attempts to comprehend the cosmos. Of course, these traditional cyclic cosmologies differ significantly from modern scientific models. They involve deities, spiritual forces, or metaphysical principles that have no place in contemporary physics. But the structural similarity, the recognition that what appears to be beginning and ending might be transition points in a greater cycle, suggests that the concept of cosmic renewal touches something deep in human thought. As we continue exploring these possibilities, we should maintain epistemological humility. Our current theories, however sophisticated, are approximations based on limited observations. The universe has repeatedly proven stranger and more complex than our most advanced models predict. The distinction between cyclic and linear cosmologies may itself be an oversimplification. Perhaps reality incorporates elements of both in ways we can't yet conceptualize. What we can say with confidence is that the simple narrative of a universe that began once with the Big Bang and will end once with heat death or some other terminal state is increasingly questioned by serious cosmologists. The boundaries between beginning and ending, creation and destruction, have grown more complex and nuanced as our understanding has advanced. We stand at a fascinating moment in cosmological history, poised between competing models of cosmic evolution, equipped with increasingly powerful observational tools and driven by questions that touch the very foundation of reality. Whether the universe proves to be linear or cyclical, finite or infinite, the quest to understand its nature connects us to the deepest human tradition of cosmic inquiry, the attempt to comprehend not just how the universe works, but why it exists at all, and what our place within it might be. If the universe is indeed a loop with no end, then there is no edge, no absolute boundary, no ultimate beginning or final conclusion. There is only the endless dance of cosmic evolution, the eternal transformation of energy and matter through infinite cycles of expansion and contraction, complexity and simplicity, order and disorder. And we, conscious beings capable of contemplating these mysteries, are not merely observers of this cosmic process, but participants in it. Arrangements of atoms that have momentarily become aware of the greater pattern of which they form a part. As you consider this possibility, look up at the night sky, at the ancient light of distant stars and galaxies journeying across the cosmos to reach your eyes. Those photons may carry not just the story of our universe, but the faint echoes of previous cosmic incarnations, whispers from an endless cycle of death and rebirth that stretches infinitely backward and forward in what we call time. You are gazing not just into space, but into the face of eternity, a cosmos that may have never truly begun and may never truly end, but simply is, was, and always will be, transforming endlessly from one state to another in the greatest cycle of all. The early universe wasn't just hot. It was a furnace where time itself was still learning to move. In that primordial plasma, with temperatures trillions of times hotter than the center of the sun, the distinction between energy and matter blurred. Particles formed and annihilated each other in cosmic dances that played out across intervals so brief they make microseconds seem like eternities. Space wasn't just expanding, it was stretching so violently that regions once in intimate contact were torn apart, never to interact again, creating the cosmic horizons that limit our observation even today. But this plasma phase, extreme as it was, represented relative stability compared to what came before. In the first trillionth of a trillionth of a trillionth of a second, after what we call the Big Bang, during the inflationary epoch, the universe expanded faster than the speed of light. This wasn't matter moving through space. It was space itself stretching exponentially, doubling in size with each unimaginably brief interval. A region smaller than a proton expanded to astronomical scales in less time than it takes light to cross an atomic nucleus. This process smoothed out irregularities, flattened cosmic curvature, and diluted any exotic particles or topological defects that might have formed in the universe's earliest moments. It created our vast, uniform cosmos from an infinitesimal seed, a quantum fluctuation blown up to cosmic proportions by inflation's incredible expansion. But what triggered inflation? What powered this brief but critical period of hyperexpansion? And what caused it to end, transitioning the universe to the more sedate expansion we observe today? These questions take us to the frontier of theoretical physics, where speculative models abound, but definitive answers remain elusive. Some theories suggest inflation was powered by a hypothetical field called the inflaton, which briefly dominated the universe's energy density before decaying into the particles we observe today. Others connect it to phase transitions in fundamental forces, similar to how water can suddenly transform from liquid to solid when cooled below freezing. Still, others tie it to extra dimensions, brains, or when physicists trace the history of our universe backward, they encounter a perplexing limit, a boundary where our most fundamental theories simply break down. As we rewind through cosmic history, space contracts, matter grows denser, temperatures rise exponentially. Eventually, roughly 13.8 billion years ago, our best mathematical models predict a state of infinite density and temperature, where space-time curvature becomes infinite, a gravitational singularity. This mathematical breaking point, this cosmic division by zero, has long been interpreted as the universe's absolute beginning, the moment of creation, the tiaro that started everything. But what if this interpretation is fundamentally flawed? What if the singularity isn't a beginning at all, but merely a symptom of incomplete mathematics, a sign that our theories are missing something crucial? Imagine a medieval mapmaker charting unknown territories. At the edges of their knowledge, they might inscribe, "Here be dragons," not because they genuinely believed dragons existed there, but because they lacked information about what truly lay beyond. The Big Bang singularity may be our modern cosmological "here be dragons," not an actual physical reality, but a placeholder marking the boundaries of our current understanding. Einstein's general relativity, our best theory of gravity, predicts this singularity. Yet Einstein himself never fully accepted this consequence of his own equations. He recognized that when physical quantities become infinite, it signals a breakdown in the theory rather than an accurate description of reality. No physical parameter can truly be infinite. Such values are mathematical artifacts, not physical realities. The problem runs deeper. When matter is compressed beyond a certain density, quantum effects become crucial. Yet general relativity, a classical theory, doesn't incorporate quantum mechanics. It's as if we're trying to understand the ocean depths using only the laws of surface waves, ignorant of the fundamentally different physics operating in the crushing pressures of the abyss. This theoretical gap has prompted physicists to develop frameworks that might peer beyond the apparent singularity, theories that merge quantum mechanics with gravity and potentially reveal what happened at the supposed beginning. These quantum gravity approaches suggest something remarkable. The singularity may be an illusion. The universe's apparent beginning might instead be a transition point, a cosmic phase change, a moment of rebirth rather than birth. Loop quantum cosmology, emerging from the broader theory of loop quantum gravity, offers one such perspective. In this framework, space itself consists of discrete units, quantum atoms of geometry with minimum possible size. When the universe contracts to extreme density, these quantum geometric effects generate an enormous pressure that counteracts gravity, causing a bounce rather than a collapse to a singularity. Imagine compressing a cosmic spring. Classical physics would suggest you could compress it infinitely small. But quantum mechanics reveals that at the smallest scales, the spring's compression becomes governed by discrete quantum leaps rather than continuous compression. Eventually, the quantum nature of space itself resists further compression, causing the spring to rebound. This quantum bounce would be like nothing we can directly visualize. Before the bounce, the universe would be contracting, growing denser and hotter. At the bounce point, lasting perhaps 10^43 seconds, the infinitesimal Planck time, quantum gravitational repulsion would overcome classical attraction. The universe would transition from contraction to expansion, from increasing to decreasing density, without ever reaching a true singularity. Space-time would remain well-defined throughout, with finite values for all physical quantities. If this scenario is correct, then what we call the Big Bang wasn't the beginning of everything, but a transitional moment, the universe's passage through a cosmic keyhole from a previous phase of contraction to our current phase of expansion. Our universe would be like a cosmic phoenix, not born from nothing, but reborn from the compressed remains of a previous cosmic cycle. The implications are staggering. If the Big Bang was a bounce rather than a beginning, then the universe existed before what we consider the start of time. There was a before the beginning, potentially an entire previous cosmic cycle of expansion, complex structure formation, and eventual contraction. Our 13.8 billion-year cosmic history might be just the visible portion of a much longer cosmic story, the latest chapter in an ongoing saga. But could such a theory be tested? Remarkably, yes. A universe that underwent a quantum bounce rather than emerging from a singularity would carry subtle observational signatures, particularly in its primordial gravitational waves, ripples in the space-time from the universe's earliest moments. In a conventional inflationary Big Bang, these gravitational waves would show a particular pattern across different wavelengths. In a quantum bounce scenario, the gravitational wave spectrum would differ, with potentially observable consequences for the polarization patterns in the cosmic microwave background radiation, the oldest light in our universe, and for the distribution of galaxies throughout space. Future space missions and ground-based observatories are being designed to detect these primordial gravitational waves with unprecedented sensitivity. Within decades, we may have observational evidence that either supports or contradicts the bounce hypothesis. The singularity that has defined our cosmic origin story for nearly a century may be experimentally tested, potentially revealed as a theoretical mirage rather than a physical reality. This possibility, that the universe never truly began but has always existed in some form, resonates with ancient philosophical traditions. Aristotle argued for an eternal universe without beginning or end. Various Eastern cosmologies conceive of endless cycles of cosmic creation and destruction. Perhaps our ancestors intuited something that our most advanced mathematics is only now rediscovering, that absolute beginnings are conceptually problematic, that something cannot come from nothing, that existence may be an eternal process of transformation rather than a one-time event. But the quantum bounce isn't the only alternative to a true singularity. String theory, which models fundamental particles as tiny vibrating strings rather than dimensionless points, offers another perspective. When matter is compressed to extreme densities, the conventional notion of space-time dissolves, replaced by a more fundamental stringy reality, where our intuitive concepts of beginning lose meaning. In some string theory scenarios, what appears as a Big Bang singularity from our perspective is actually a transition between different geometric configurations of those extra dimensions that string theory requires. Our three-dimensional universal expansion might be a shadow play, a projection of more fundamental processes occurring in higher dimensions, similar to how a two-dimensional shadow can be cast by a three-dimensional object. These alternatives to the traditional singularity confront us with a profound possibility. Our universe did not emerge from nothing in a singular creation event. It may instead be an eternal entity, taking different forms, passing through different phases, but ultimately without absolute beginning or end. The apparent singularity would then be a cosmic sleight of hand, an illusory edge to reality that disappears when viewed with more advanced theoretical tools. But why should we care? Whether the universe began with a singular Big Bang or has cycled eternally might seem like an abstract academic dispute without practical consequence. Yet it fundamentally reshapes how we conceptualize our cosmic context, our relationship to time, and ultimately, our place in the universe. In a universe with a definite beginning, we exist at a particular moment in a linear cosmic history that stretches from creation to eventual dissolution. In an eternal cyclic cosmos, we participate in one phase of an endless pattern, a cosmic rhythm that has no first beat and will have no final note. These different cosmological frameworks don't just describe different physical realities. They place us in fundamentally different metaphysical contexts with profound implications for how we understand our existence. Time's great illusion. If the singularity dissolves under careful theoretical scrutiny, so too might our conventional understanding of time itself. We intuitively perceive time as flowing, a cosmic river carrying us from past to future at a fixed rate. But modern physics suggests this perception may be as illusory as the apparent movement of the sun across the sky. Einstein's relativity demolished the notion of absolute universal time. There is no cosmic clock ticking at the same rate for all observers. Time passes differently, depending on relative motion and gravitational fields. Two twins, one remaining on Earth while the other travels at near light speed, will age at different rates. The traveling twin will return younger than the Earth-bound sibling, not just by appearance, but in every measurable biological and physical sense. This isn't mere theoretical speculation. It's confirmed by precise atomic clocks on airplanes and satellites. GPS systems must correct for these time dilation effects to function accurately. Time truly flows at different rates, depending on velocity and gravitational potential. But relativity goes further, suggesting that past, present, and future may all exist simultaneously in what physicists call a block universe. In this view, time doesn't flow. Rather, reality is a four-dimensional structure where all moments, past, present, and future, exist with equal reality. Our sense of now, moving from past to future, may be a psychological phenomenon rather than a fundamental aspect of reality. Imagine reality as a film reel, where time is not flowing, but every moment already exists. Our consciousness illuminates one frame at a time, creating the illusion of temporal flow. Each frame, each moment, exists regardless of whether consciousness is currently experiencing it. The physicist Brian Greene explains it this way: just as we think of all of space as being out there, as really existing, we should think of all of time as being out there, as really existing too. Past, present, and future certainly appear to be distinct entities. But according to Einstein, this is a myth. If time is truly a dimension rather than a flow, if the future already exists in some sense, then the common-sense notion of the universe beginning becomes problematic. Beginnings and endings are temporal concepts that presuppose a flowing time. In a block universe, the totality of cosmic history, including what we call the beginning and the end, simply exists as a complete four-dimensional structure. But this raises a troubling question. If the future already exists in a fixed form, what happens to causality? What happens to free will? Are our actions predetermined links in an unchangeable causal chain stretching across the block universe? These questions become even more complex when we consider quantum mechanics, which introduces fundamental indeterminism into our understanding of nature. At the quantum level, future states aren't rigidly determined by present conditions. They're described by probability distributions with multiple potential outcomes coexisting in a state of quantum superposition until measurement collapses the possibilities into a single reality. Reconciling quantum indeterminism with relativistic block. Time remains one of physics' great unsolved puzzles. Various interpretations of quantum mechanics, from the Copenhagen interpretation to the many worlds interpretation to quantum Bayesianism, offer different perspectives on how these apparently contradictory aspects of reality might coexist. This quantum relativistic tension becomes particularly acute when considering a cyclic universe. If time isn't a linear flow but a dimension, and if quantum effects prevent true determinism, how should we conceptualize cosmic cycles? Are they predetermined repetitions, variations on a theme, or fundamentally new creations each time? Some theorists suggest a perspective that transcends the dichotomy between flowing time and block time. In this view, reality's basic ingredients aren't objects persisting through time, but events, occurrences that have inherent temporal extension. The universe would be a network of interrelated events rather than a collection of objects moving through time or a static four-dimensional block. This event-based ontology might better accommodate both relativity's space-time unity and quantum mechanics' fundamental indeterminism. It might also provide a framework for understanding cosmic cycles not as repetitions of the same process, but as new events that bear family resemblances to previous cycles without being identical to them. The physicist Carlo Rovelli, a proponent of loop quantum gravity, suggests that time as we experience it emerges from more fundamental quantum processes that themselves don't unfold in time as we understand it. At the deepest level, reality wouldn't be temporal or atemporal, flowing or static, but something that generates both temporality and stasis as different perspectives on a more basic reality. This sounds abstract, but it addresses a fundamental problem with cyclic cosmologies. If time is cyclical, then what tracks the progression of cycles? Is there a meta-time that itself flows linearly while cosmic time loops? Or should we abandon the very concept of flow, whether circular or linear, as a fundamental reality? Perhaps the imagery of film can help again. Instead of a linear film strip or a looping reel, imagine a more complex structure. A film that contains within itself the mechanics for its own projection, where each frame both displays its content and changes the projector in subtle ways. The film wouldn't just show consecutive images, it would alter how the next frame is projected based on the current frame. This self-modifying film might better capture the complexity of cosmic time, where the universe isn't just expanding and contracting according to fixed laws, but potentially altering the very laws and initial conditions with each cycle. Time wouldn't flow in the conventional sense, but reality would still evolve from one state to another in a non-repeating pattern that transcends simple cyclicity. But there's another possibility, one suggested by the phenomena of black holes. In these cosmic leviathans, space-time curvature becomes so extreme that standard notions of space and time break down. Past a critical threshold, the event horizon, all future paths lead inexorably inward toward the central singularity. Time and space, in a sense, exchange roles. Time becomes space-like, and movement through time becomes as inevitable as falling through space under gravity's influence. Some cosmologists have proposed that the entire universe might be understood as a temporal counterpart to a black hole, a white hole that ejects matter and energy rather than consuming them. Our expanding universe, in this view, would be like the time-reversed version of matter falling into a black hole. The Big Bang wouldn't be the beginning of time, but a boundary similar to a black hole's event horizon, a point beyond which we cannot see because the laws of physics as we understand them break down. This perspective suggests that time as we experience it might be a limited, local phenomenon, applicable within a certain cosmic regime, but breaking down at the extremes, of density and energy typical of the early universe or black hole interiors. Our intuitive understanding of temporal flow, cause and effect, before and after, might be provincialisms, perspectives valid in our cosmic neighborhood, but not universally applicable. If true, this would fundamentally alter how we conceptualize cosmic cycles. Instead of thinking of the universe as moving through time, whether linearly or cyclically, we might understand cosmic cycles as transitions between different regions of a more complex space-time structure. Regions where conventional notions of temporality apply differently or not at all. This brings us to the dizzying possibility that what appears as temporal sequence from one perspective might manifest as spatial arrangement from another. The apparent succession of cosmic cycles might be, from a higher dimensional viewpoint, a spatial pattern rather than a temporal sequence, like different regions of a vast landscape rather than consecutive chapters of a cosmic story. Such perspectives strain our conceptual frameworks and push language to its limits. They remind us that our intuitive notions of time, flowing, directional, universal, evolved for navigating the middle scales of reality, the realm of moderate sizes, speeds, and gravitational fields that our ancestors encountered. At the extremes of the very small and the very large, the very dense and the very energetic, these intuitions may be as misleading as flat Earth thinking. A truly cyclic cosmos might require us to develop new conceptual tools, new metaphors, perhaps even new mathematics to properly describe its nature. Our conventional vocabulary of beginnings and endings, before and after, past and future, might be inadequate for capturing a reality where time itself emerges from deeper structures that aren't inherently temporal. As the philosopher Martin Heidegger observed, we are thrown into time. Our very being is temporal. We cannot easily step outside time to observe it objectively. any more than fish can step outside water to study hydrodynamics. Our theories about time's nature are themselves formulated within time, creating potential, blind spots, and conceptual limitations that we can only partially transcend. Yet despite these limitations, physics has made remarkable progress in unveiling time's complex nature. From Einstein's relativity to quantum mechanics to contemporary theories of quantum gravity, we've developed mathematical frameworks that capture aspects of temporal reality that transcend our intuitive understanding. These frameworks suggest that time may be neither the linear flow nor the perfect cycle that our ancestors envisioned, but something more subtle and complex, perhaps an emergent phenomenon arising from more fundamental timeless processes. If this is true, if time as we experience it isn't a fundamental reality, but an emergent property, then the question of whether the universe is linear or cyclical transforms. Both linearity and cyclicity presuppose time as a basic ingredient of reality. But if time emerges from timeless foundations, then the universe might be neither linear nor cyclical in any simple sense, but structured in ways that generate both linear and cyclical aspects depending on the scale and perspective from which it's observed. This possibility that our most basic concepts for describing reality might be provisional approximations rather than fundamental truths isn't cause for despair, but for wonder. It suggests that the universe is richer and stranger than our evolved intuitions can directly grasp, yet partially accessible through the abstract language of mathematics and the disciplined imagination of theoretical physics. As we contemplate these possibilities, we're engaging in a tradition as old as humanity itself, the attempt to understand time's mysteries, to make sense of our temporal existence, to place our brief lives in the context of cosmic duration. From ancient myths of eternal return to modern theories of block universes, humans have grappled with time's enigmas, seeking frameworks that make sense of our temporal experience while acknowledging its paradoxes and limitations. Perhaps the ultimate truth about cosmic time, whether it flows linearly, cycles eternally, or emerges from deeper timeless structures, lies beyond what we can currently conceive. But the quest to understand it connects us to both our ancestral past and our cosmic context, reminding us that we are not just in time, but of time. Temporal beings seeking to comprehend the very temporality that constitutes our existence. Infinite. Mirrors. The multiverse. Hypothesis. The mystery deepens further when we consider another revolutionary concept in contemporary cosmology: the multiverse. This isn't science fiction, but a serious theoretical possibility emerging from our most successful physical theories. The universe we observe, the entire cosmic horizon visible to our most powerful telescopes, may be just one region of a vastly larger reality that contains uncountable other universes, each with potentially different physical laws, constants, particles, and forces. Several independent theoretical approaches converge on this multiverse concept, suggesting it isn't merely speculative but a natural consequence of established physical frameworks. Let's explore these approaches and their implications for our cyclic universe hypothesis. Eternal inflation theory, an extension of cosmic inflation, suggests that the process that caused our observable universe's initial exponential expansion never completely stops. In most regions, inflation eventually ends, allowing matter to condense, stars to form, and conventional cosmic evolution to proceed. But inflation continues eternally in other regions, creating an ever-expanding network of bubble universes, separated by still inflating space. In this scenario, our observable universe is just one bubble in a vast cosmic foam, one pocket of conventional space-time in an eternally inflating background. Each bubble would have its own Big Bang, its own subsequent evolution, its own eventual fate. Some might expand forever. Others might recollapse. Some might have physical constants conducive to complex structures and life. Others might be sterile, perhaps unable even to form atoms. This inflationary multiverse gives us cosmic siblings, parallel universes with potentially different physical laws, all emerging from the same fundamental inflating background. But it doesn't inherently provide a cyclic model for our particular universe. For that, we need to consider other multiverse theories. String theory, our most developed approach to quantum gravity, suggests another kind of multiverse. According to string theory, physical reality at the most fundamental level consists of tiny vibrating strings whose oscillation patterns determine the properties of the particles we observe. This framework requires extra spatial dimensions beyond the three we experience. Dimensions curled up so tightly they remain invisible to us. These extra dimensions can be compactified in something like 10^500 different ways, each producing a different set of physical laws, constants, and particle properties. This vast landscape of possibilities suggests a multiverse where different regions realize different compactification patterns, creating an unimaginable diversity of physical realities. Some regions in this string theory landscape might have the properties necessary for cyclic evolution, the right balance of forces to enable expansion followed by contraction, then another expansion. Others might expand forever or might collapse once without rebounding. Our universe's apparent fine-tuning for complexity and life might result not from design, but from our existence in one of the rare regions with life-permitting properties. Yet another multiverse theory emerges from quantum mechanics itself. The many-worlds interpretation, first proposed by Hugh Everett III, suggests that quantum reality doesn't collapse into a single outcome when measured. Instead, reality branches, creating multiple worlds where each possible outcome is realized. Every quantum event that could go different ways spawns new branches, creating an ever-proliferating tree of alternate realities. If true, this quantum multiverse would contain versions of our universe that differ in the outcomes of quantum events, perhaps subtly different in the position of a single particle, or dramatically different in the evolution of complex systems sensitive to quantum fluctuations. Some branches might evolve toward conditions that enable cosmic contraction and rebirth. Others might expand forever. These various multiverse theories aren't mutually exclusive. Reality might contain all three types simultaneously: inflationary, bubble universes, each with different string theory compactifications, each branching into quantum alternate realities. The physicist Max Tegmark has proposed a hierarchical classification of multiverse types, arguing that each level emerges naturally from established physics. But what does this vast proliferation of universes mean for our question about cosmic cycles? It suggests several fascinating possibilities. First, cyclicity might be just one pattern among many in the multiverse. Some universes might be cyclic, others linear. Our universe's specific properties might determine whether it cycles eternally or follows a one-time trajectory from Big Bang to eventual dissolution. Second, what appears as temporal cycles within our universe might actually represent spatial relationships in a higher dimensional multiverse. Our cosmic history, including apparent deaths and rebirths, might be a slice through a more complex structure that isn't inherently temporal. Imagine an infinite stack of parallel two-dimensional sheets. A creature confined to one sheet might perceive the stack structure as a temporal sequence, experiencing before and after what is actually above and below in the higher dimensional arrangement. Similarly, our perception of cosmic cycles might be a temporal projection of spatial relationships in extra dimensions. Third, the multiverse might itself undergo cycles of creation and destruction at a meta-level, with entire ensembles of universes, going through phases of expansion, proliferation, contraction, and rebirth. Some theories suggest the multiverse might have multiple vacua, states of minimum energy, and could transition between them over vast timescales, potentially creating cyclical behavior at a scale far beyond our observable universe. Most intriguingly, some theories suggest information might transfer between universe cycles or between different regions of the multiverse. This transfer wouldn't involve conventional signals traveling faster than light, which relativity forbids, but might occur through quantum entanglement, gravitational effects, or processes operating in extra dimensions. If such information transfer occurs, it raises profound questions. Could the initial conditions of our universe, the specific patterns of density fluctuations that seeded all subsequent cosmic structure, contain subtle imprints from previous cycles or neighboring universes? Might there be observable consequences we could detect with sufficiently advanced technology? Some researchers have searched for statistical anomalies in the cosmic microwave background radiation that might indicate influences from beyond our observable universe. Others have proposed that certain mysterious aspects of our cosmos, dark energy's precise value, for instance, or the apparent fine-tuning of physical constants, might be explained by information flowing from other regions of the multiverse. Physicist Lee Smolin has proposed a fascinating variation on these ideas called cosmic natural selection. In this scenario, black holes might spawn new universes, with each offspring universe having slightly different physical parameters than its parent. Universes that produce many black holes would generate more cosmic offspring, creating an evolutionary process that might explain why our universe has the particular properties we observe. This concept suggests a kind of cosmic heredity, an inheritance of physical traits across universe generations that mimics biological evolution. If true, our universe's ability to form complex structures, including life, might be connected to its ability to produce black holes, which in turn create new universes with similar fertility. Such speculations might seem to verge on science fiction, but they're based on serious theoretical work and might potentially generate testable predictions. They represent attempts to extend our understanding beyond the limits of our observable universe, to contextualize our cosmic home within a larger reality that might be far stranger and more diverse than we've traditionally imagined. The multiverse concept also transforms our understanding of what eternal might mean in the context of cyclic cosmologies. Instead of a single universe cycling endlessly through time, we might envision a vast ensemble of universes, each with its own temporal pattern, together forming a metastructure that has no beginning or end, even if individual universes do. This perspective resonates with ancient philosophical intuitions about infinity and eternity. The pre-Socratic philosopher Anaximander proposed an infinite cosmos where worlds are continually born and die, maintaining an eternal balance. Eastern traditions like Buddhism and Hinduism envision vast cosmic cycles nested within larger cycles, extending to scales beyond human comprehension. The multiverse theory gives these ancient intuitions a modern mathematical framework, suggesting that reality may indeed be infinite in both space and time, or perhaps in dimensions that transcend simple spatial and temporal description. It suggests that our universe, whether it cycles eternally or follows a linear path, is part of something vaster and more enduring. But this vastness raises profound questions about meaning and purpose. If our universe is one among countless others, does that diminish its significance? If cosmic cycles repeat endlessly, does that render our particular cycle, our cosmic moment, less meaningful? Some find such questions discouraging, seeing in the multiverse's vastness a reduction of human significance to infinitesimal proportions. Others find liberation and wonder in the same concept, viewing the multiverse as an infinite canvas of possibilities where everything physically possible exists somewhere, somewhen. The philosopher Friedrich Nietzsche anticipated some of these questions in his concept of eternal recurrence, the hypothetical idea that everything that happens has happened infinitely many times before and will happen infinitely many times again. He asked whether we could affirm existence if it repeats eternally, with all its joys and sorrows, triumphs and tragedies. For Nietzsche, this affirmation represented the highest possible yes-saying to life. In the context of modern multiverse theories, Nietzsche's question takes on new dimensions. If reality is sufficiently vast, whether through eternal cosmic cycles, infinite spatial extent, or branching quantum worlds, then configurations identical or nearly identical to our current existence may indeed recur, not through mystical forces, but through the mathematically inevitable repetition of patterns in a sufficiently large or long-lived ensemble. Physicist Brian Greene describes this possibility. If the spatial expanse is infinite, then no matter how unlikely it is for identical copies of you and me and our entire observable universe to exist elsewhere, on the infinite landscape, there are such regions. This concept of Boltzmann brains and repeated identical configurations emerges from basic principles of probability applied to infinite space and time. Given enough cosmic real estate or enough temporal cycles, eventually particles will randomly arrange themselves into configurations identical to our current reality, including our brains with all their memories and perceptions. Such concepts strain our intuitions about identity, consciousness, and individuality. Are these identical copies truly us? Does their existence affect the meaning of our lives? These questions transcend physics, entering philosophy and metaphysics, yet they emerge naturally from our best physical theories about the cosmos and its potential multiplicity. The multiverse concept also transforms traditional theological questions about creation and design. The apparent fine-tuning of our universe for complexity and life, the precise values of physical constants that allow for stars, planets, and biochemistry, has sometimes been interpreted as evidence for intelligent design. But in a vast multiverse where different regions have different physical properties, life naturally emerges in those rare regions with suitable parameters. No designer is needed. Given enough universes, life-permitting ones will exist by chance, alone. This doesn't disprove the existence of a designer or creator, but it does show that fine-tuning alone doesn't require one. The multiverse provides a naturalistic explanation for why we observe a universe apparently fine-tuned for our existence. We could only exist in such a universe to make the observation. This is the anthropic principle, a selection effect that helps explain apparent cosmic design without invoking a designer. But the multiverse raises new questions even as it answers old ones. If our universe is one bubble in a vast cosmic foam, or one branch in an endless quantum tree, or one valley in an immense landscape of string theory possibilities, what generated this larger structure? What are its governing laws? Does the concept of creation apply to the multiverse as a whole, even if individual universes emerge through natural processes? These questions may be accessible to scientific investigation despite their seemingly metaphysical nature. The multiverse hypothesis, despite involving regions beyond our direct observation, isn't necessarily unscientific. If it makes testable predictions about our observable universe, predictions that differ from those of single universe models, then it enters the realm of empirical science. Some potential tests include statistical patterns in the cosmic microwave background radiation that might indicate collisions with other bubble universes or influences from beyond our cosmic horizon, unexpected values for fundamental constants, or unexpected relationships between them that might point to selection effects operating across a multiverse, signatures of cosmic events just before the Big Bang that might reveal information from a previous cycle or a parent universe. While conclusive evidence remains elusive, these avenues of investigation show that the multiverse isn't merely philosophical speculation, but a scientific hypothesis with potential observational consequences. The multiverse concept also transforms how we think about cosmic cycles. Instead of a single universe repeating the same pattern eternally, we might envision a vast ensemble of universes, each with its own life cycle, together forming a metastructure that continues infinitely even if individual universes don't. This perspective offers a kind of cosmic immortality without requiring that our specific universe endure forever. Even if our universe eventually succumbs to heat death, expansion to emptiness, or catastrophic collapse, the larger reality of which it forms a part continues generating new universes, new possibilities, new forms of complexity and consciousness. Such a vision has poetic resonance with ancient myths of cosmic renewal, the phoenix rising from its ashes, the serpent swallowing its tail. The endless cycles of death and rebirth in Eastern traditions all find echoes in modern multiverse cosmologies, albeit transformed by the precision of mathematical physics and observational astronomy. But perhaps the most profound implication of the multiverse for our exploration of cosmic cycles is this: it frees us from the false dichotomy between a universe that cycles eternally and one that has a definite beginning and end. Reality might encompass both possibilities simultaneously, with some universes cycling while others follow linear trajectories, together forming a meta-pattern that transcends simple categorization as either cyclical or linear. This integrative perspective suggests that the most fundamental properties of reality might not be captured by our conventional either-or categories. The universe, or multiverse, might be neither simply eternal nor simply finite, neither purely cyclical nor purely linear, but structured in ways that generate both eternity and finitude, both cycles and arrows, depending on the scale and perspective from which they're observed. Such a reality would be too complex to fully capture in language or intuitive visualization, accessible primarily through the abstract language of mathematics, but it would also connect to deep intuitions about infinity, eternity, and the interplay of pattern and novelty that have animated human thought across cultures and through millennia. As we contemplate these possibilities, we're engaging with questions that have both scientific and philosophical dimensions. Questions about the nature of time, the meaning of infinity, the structure of reality at its most fundamental level. These questions remind us that cosmology isn't merely a technical discipline, but a continuation of humanity's oldest intellectual quest to understand our place in the cosmos and the nature of the reality we inhabit. The black hole. Enigma Black. Holes represent cosmic paradoxes made manifest, regions where matter collapses to such extreme density that space-time curves beyond recognition, where gravity becomes so intense that not even light can escape. These gravitational leviathans challenge our most fundamental physical theories and may hold crucial clues to the cyclical nature of the universe. When a massive star exhausts its nuclear fuel, its core collapses under gravity's relentless pull. With nothing to counteract this inward pressure, matter compresses beyond atomic scale, beyond nuclear density, potentially to a mathematical point of infinite density called a singularity. Surrounding this singularity is the event horizon, a boundary in space-time beyond which nothing can return to the outside universe. This classical picture derived from Einstein's general relativity, presents black holes as cosmic one-way streets. Matter and energy fall in but can never emerge. Information that enters a black hole appears permanently lost to the outside universe, creating what physicists call the information paradox. Quantum mechanics, however, tells a different story. According to Stephen Hawking's groundbreaking work, black holes aren't entirely black. They emit a faint radiation resulting from quantum effects near the event horizon, gradually losing mass and eventually evaporating completely. This Hawking radiation carries energy away from the black hole, but apparently not in a form that preserves information about what fell in. This creates a profound conflict between general relativity, which says information is lost inside black holes, and quantum mechanics, which insists information must be preserved. The resolution of this paradox may have profound implications for understanding cosmic cycles. Some theoretical approaches suggest that information isn't truly lost in black holes, but encoded on their event horizons. According to the holographic principle, the information content of any region of space can be represented by information on the boundary of that region. Applied to black holes, this means that everything that falls into a black hole leaves its informational fingerprint encoded on the event horizon. When a black hole eventually evaporates through Hawking radiation, this encoded information might be released back into the universe in a highly scrambled but theoretically decodable form. Information wouldn't be destroyed, but transformed and eventually returned to the cosmos. This principle might extend to the entire universe. Some theories suggest our three-dimensional reality might be a projection of information encoded on a distant two-dimensional boundary, like a hologram projected from a flat surface. Our perception of depth, of three-dimensional space extending over billions of light-years, might emerge from more fundamental processes operating on this boundary. If true, this would transform how we understand cosmic cycles. The apparent death of a universe, whether through endless expansion, contraction to a singularity, or some other fate, might not represent true information loss, but a transformation of information that could seed another cycle. Leonard Susskind, one of the founders of string theory, has suggested that black holes might connect to other regions of space-time or even to other universes. When matter falls into a black hole in our universe, it might emerge as a white hole, a time-reversed black hole that ejects matter and energy in another region of a larger cosmic structure. This scenario resembles certain cyclic cosmologies. Just as matter falling into black holes might emerge elsewhere in a transformed state, our entire universe might undergo a similar process, collapsing in one form only to re-emerge in another. Recent theoretical work has explored the possibility that black holes might give birth to new universes. The extreme conditions at a black hole's center, where space-time curvature and energy density approach infinity, resemble the conditions theorized for the Big Bang. Some models suggest that when matter collapses beyond a certain threshold, space-time might bounce rather than form a true singularity, inflating into a new expanding region disconnected from our universe. If so, the vertigo of infinite recursion, take a deep breath. Feel the air filling your lungs. Notice the weight of your body, the texture of this moment, the certainty that you are here, now, experiencing this singular instant of existence. Now consider this. What if every atom in your body, every neural firing in your brain, every thought and feeling you're experiencing right now has already happened before, not once, but infinite times? And what if it will happen again, endlessly, in precisely the same way throughout eternity? This isn't merely a philosophical thought experiment. If the universe truly cycles eternally, the immensity of time combined with the finite number of possible particle arrangements means that eventually, inevitably, the exact configuration that constitutes you reading these words must recur. Physics, not mysticism, demands it. The mathematician Poincaré proved that any system with finite energy confined to a finite volume will, after a sufficiently long time, return arbitrarily close to its initial state. If the universe cycles, with each cycle containing finite energy, in finite volume, then given enough cycles, and eternity provides more than enough, everything must repeat. The implications are vertiginous. Your first kiss, your deepest regret, the moment of your death. In an eternally cycling cosmos, these aren't one-time events but recurrences playing out over and over across the vast tapestry of cosmic time. Imagine standing between two mirrors, seeing your reflection repeated infinitely in both directions. That's your existence in a cyclic universe. Extending infinitely backward and forward, identical copies of you living the same life, making the same choices, experiencing the same joys and sorrows, backward into an infinite past and forward into an infinite future. This perspective obliterates our intuitive sense of uniqueness and originality. Every thought you've ever had that felt novel and personal has been thought before by beings identical to you in previous cycles. The love you feel, the insights you treasure, the pain you've endured, all have been experienced countless times by your cosmic doppelgangers. Does this realization fill you with dread or comfort? Does it render life meaningless, knowing it's all been lived before and will be lived again? Or does it infuse each moment with a kind of eternal significance, knowing that this fleeting experience is preserved and repeated in the infinite recursion of cosmic cycles? Friedrich Nietzsche called this concept eternal recurrence and considered it the ultimate test of life affirmation. Could you embrace existence so completely that you would willingly live the same life, with all its pain and darkness, as well as its beauty and joy, over and over for eternity? What if a demon were to creep after you one day or night, Nietzsche wrote, and say to you, "This life as you live it now and have lived it, you will have to live again and again, innumerable times, and there will be nothing new in it, but every pain and every joy and every thought and every sigh must return to you, all in the same succession and sequence." Would you not throw yourself down and curse that demon? Or have you once experienced a tremendous moment in which you would answer him, "You are a god, and never did I hear anything more divine"? The cyclic universe presents us with Nietzsche's demon in the form of physics equations and cosmological models. It asks us whether we can affirm existence so completely that we would accept its eternal repetition. But the existential vertigo deepens when we consider quantum mechanics. In the quantum realm, particles exist in states of superposition, occupying multiple positions or having multiple properties simultaneously until measured. Applied to cosmic cycles, this suggests each cycle might not be identical to the last, but represent one possible quantum outcome among many. Imagine not just infinite identical copies of yourself stretching through cosmic time, but infinite variations, some nearly identical, differing perhaps in a single thought or choice, others dramatically different, living lives unrecognizable from your own. All of these variants would be equally real, equally you in some sense, existing in different cycles or different quantum branches of the same cycle. This quantum perspective transforms the eternal recurrence from a repetition of the same to a flowering of possibilities, not just one life lived countless times, but countless possible lives lived across the infinity of cycles. Your existence becomes not a single thread repeating through cosmic time, but a vast tapestry of potential selves, each experiencing different versions of reality. Is this more or less dizzying than the notion of perfect repetition? Does it provide greater freedom, knowing that somewhere in the cosmic cycles, versions of you make different choices? Or does it undermine the significance of your particular experience, rendering it just one arbitrary path among infinite alternatives? As you contemplate these questions, you're engaged in an act that connects you to a fundamental human response to cosmic immensity, the attempt to reconcile our finite subjective experience with the vastness of physical reality. This tension between human scale and cosmic scale, between lived experience and abstract understanding, generates what philosopher Peter Wessel Zapffe called cosmic panic, the vertigo induced by confronting the universe's true proportions. Look at your hand. Behind its familiar appearance lies an abyss of complexity. Trillions of atoms, each containing subatomic particles separated mostly by empty space, all obeying quantum laws that defy intuitive understanding. The solid flesh you perceive is largely void, its apparent continuity a convenient illusion generated by your brain to navigate the world. Zoom out further. The planet you inhabit is a mote of dust orbiting an ordinary star amid 400 billion others in the Milky Way, itself one galaxy among hundreds of billions in the observable universe. The cosmic space between stars is so vast, so empty, that even traveling at light speed, the universe's fundamental speed limit, it would take years, centuries, millennia to cross. And these are just the three spatial dimensions we directly perceive. String theory suggests additional dimensions curled up at scales too small to observe. Multiverse theories propose entirely separate universes beyond our own. The full reality may be far stranger and more extensive than we can visualize or intuitively grasp. Now add the temporal dimension. If the universe cycles eternally, then the entire 13.8 billion-year cosmic history we've pieced together, from Big Bang to the formation of stars and galaxies, to the emergence of life on Earth to this present moment of human civilization, represents just one heartbeat in an infinite cosmic pulse. The cosmologist Carl Sagan attempted to render cosmic scales comprehensible by compressing the universe's history into a single Earth year. On this calendar, the Big Bang occurs on January the 1st. Galaxies form in May. Our solar system appears in September. Life on Earth emerges shortly after. But humans arrive only in the final minutes of December 31st. All of recorded human history occupies the last seconds before midnight. This perspective is humbling enough. But in a cyclic universe, even this compressed cosmic year represents just one tick of an infinite clock. One cycle among countless others stretching before and after. The entirety of human experience becomes not merely brief, but recursively brief. A fleeting moment that flashes and vanishes eternally. This is cosmic horror in the truest sense. Not monsters or aliens, but the vertiginous realization of our true position in an immensity that exceeds our evolved capacities to comprehend. It is the dread described by horror writer H.P. Lovecraft. The most merciful thing in the world, I think, is the inability of the human mind to correlate all its contents. Someday the piecing together of dissociated knowledge will open up such terrifying vistas of reality that we shall either go mad from the revelation or flee from the deadly light into the peace and safety of a new dark age. Yet this horror contains its own strange beauty. The same cosmic immensity that dwarfs us also connects us intimately to the universe's grandeur. The atoms in your body were forged in stellar furnaces billions of years ago. the iron in your blood, the calcium in your bones, the carbon in your cells, all were created through nuclear fusion in stars that exploded and scattered these elements across space before our solar system formed. As astronomer Carl Sagan poetically observed, "We are a way for the cosmos to know itself. The universe has evolved complexity sufficient to contemplate its own nature. Through you, through your consciousness, the cosmos experiences and reflects upon itself. If the universe cycles eternally, this connection deepens further. Your atoms haven't just participated in one cosmic story, but in countless cycles of universal death and rebirth. The particles comprising your body have been recycled through infinite cosmic iterations, taking part in an eternal dance of dissolution and reconstruction. And if consciousness is an emergent property of sufficiently complex arrangements of matter, if awareness arises naturally given the right conditions, then something like your consciousness has emerged before and will emerge again across the cosmic cycles. Not you specifically, perhaps, but awareness with similar questions, similar wonder, similar appreciation for the cosmos that gave it birth. This perspective doesn't eliminate the horror of cosmic immensity, but it transmutes it, infusing the dread with awe. The philosopher Rudolf Otto called this combination of fear and fascination before the infinite mysterium tremendum et fascinans, the tremendous and fascinating mystery that forms the core of religious experience across cultures. The cyclic universe confronts us with this mysterium in its most literal form. It presents a reality so vast it shatters our conventional frames of reference, yet so intimately connected to our being that we cannot stand apart from it as mere observers. We are not merely in the cosmos, but of it, not temporary visitors, but eternal participants in its cycles. The cosmic mirror. What if the universe is not merely a physical system, but an entity that, in some sense we barely comprehend, is alive? What if, like a vast organism, it grows, evolves, dies, and is reborn in an eternal life cycle that dwarfs our understanding of biological processes? This isn't mere animism or mysticism dressed in scientific language. Complexity theorists have noted striking parallels between cosmic and biological systems. Both exhibit emergent properties, phenomena arising from simpler interactions that cannot be predicted from those interactions alone. Both display self-organizing behaviors, generating order and structure without external direction. Both evolve over time, developing greater complexity and information processing capacity. The physicist Freeman Dyson once speculated that intelligence might become the dominant force in cosmic evolution, eventually capable of influencing the universe's large-scale dynamics. If consciousness continues evolving over billions or trillions of years, might it reach a state where the distinction between mind and cosmos blurs? Might consciousness become cosmic in scale, integrated with the physical universe in ways we cannot currently imagine? If so, then the cyclic universe takes on a new dimension. Each cycle wouldn't merely repeat physical patterns, but would represent one iteration in the development of cosmic consciousness. A kind of universal learning process, extended across eternal recursive time. This speculation resonates with ancient philosophical traditions. The Stoics conceived of the cosmos as a living, rational entity of which humans form one small part. Various Hindu traditions envision the universe as the body or dream of a cosmic consciousness. Modern philosopher Alfred North Whitehead developed a process philosophy in which experience, not merely matter, forms reality's basic constituent, extending in some form throughout the cosmos. These perspectives suggest an unsettling possibility. What if we are not merely observers of the cosmos, but participants in its self-realization? What if human consciousness, indeed all consciousness, represents the universe becoming aware of itself, experiencing itself from within. In a cyclic cosmos, this self-awareness wouldn't be a one-time emergence, but a recurring phenomenon, perhaps growing more profound with each cycle, accumulating some form of cosmic memory or wisdom that transcends the death and rebirth of physical structures. Look into a mirror. The eyes staring back at you belong to a being composed of star stuff, a collection of atoms arranged in patterns complex enough to contemplate its own existence. But what if those eyes are also, in some profound sense, the universe looking at itself? What if your self-awareness is the cosmos achieving consciousness of its own nature? This isn't solipsism, the claim that only your mind exists, but its opposite. The suggestion that what you call your mind is one localized expression of a broader cosmic awareness, one wave in an infinite ocean of consciousness that cycles eternally through different forms and structures. If true, this would transform the significance of human existence. We wouldn't be accidental byproducts of blind physical processes, nor the special creation of a supernatural designer, but integral participants in the universe's self-realization, nodes of awareness through which the cosmos experiences and knows itself. This perspective raises profound questions about identity and continuity. If consciousness is cosmic in nature, localized temporarily in structures like human brains, what happens when those structures dissolve? Does the awareness they housed simply return to the cosmic whole, like a wave merging back into the ocean? Does it reconfigure in new forms across cosmic cycles? The physicist Erwin Schrödinger, one of quantum mechanics' founders, explored similar questions in his philosophical writings. Consciousness, he wrote, is never experienced in the plural, only in the singular. How does the idea of plurality, so emphatically opposed by the Upanishad writers, arise at all? Consciousness finds itself intimately connected with and dependent on the physical state of a limited region of matter, the body. Now, there is a great plurality of similar bodies. Hence, the pluralization of consciousnesses or minds seems a very suggestive hypothesis. In truth, there is only one mind. In a cyclical universe, Schrödinger's one mind wouldn't be extinguished by cosmic death, but would persist through the transition from one cycle to the next, perhaps transformed in ways beyond our current understanding. The Buddhist concept of consciousness without a permanent self, continually changing yet maintaining a kind of continuity through those changes, offers a potential model for how awareness might transcend individual cycles while still evolving across them. This cosmic perspective on consciousness also transforms how we might understand death. The dissolution of your particular bodily arrangement, your individual death, appears catastrophic when viewed from the conventional perspective of a separate, autonomous self. But if your consciousness is one expression of a unified cosmic awareness, death represents not an end but a transformation. The localized awareness you call you merging back into the greater whole from which it temporarily emerged. In a cyclic cosmos, this process would repeat eternally. Awareness would continuously localize into distinct perspectives, experience the world through those perspectives, then dissolve back into the cosmic whole, only to re-emerge in new forms in subsequent cycles. If you find this perspective disorienting, even terrifying, you're confronting what philosophers call the paradox of the self, the tension between our lived experience of being distinct individuals and the growing scientific and philosophical evidence suggesting the self is neither as unified nor as separate as it appears. Neuroscience reveals the self is not a fixed entity, but a process, a dynamic pattern maintained by the brain's ongoing activity. Cognitive science shows that much of what we attribute to the conscious self actually occurs in unconscious processes beyond our awareness or control. Various mystical and contemplative traditions report that deep meditation can temporarily dissolve the boundaries of the separate self, revealing a more fundamental unity beneath apparent division. The cyclic universe amplifies this paradox across cosmic scales. If the seemingly solid, separate self is actually a process, a temporary pattern rather than a fixed entity, then the recycling of these patterns across eternal cosmic cycles suggests a kind of immortality, but not of the individual ego we conventionally identify with. This is not immortality in the sense of your particular personality, memories and attachments continuing unchanged forever. It's immortality in the sense that the fundamental awareness that experiences reality through the temporary configuration you call you never truly dies, but cycles eternally through different forms. The 13th century Persian poet Rumi expressed this perspective. I died as a mineral and became a plant. I died as plant and rose to animal. I died as animal and I was man. Why should I fear? When was I less by dying? In a cyclic universe, Rumi's progression wouldn't end with human form, but would continue through countless transformations across infinite cosmic cycles. Consciousness eternally dying and being reborn in new configurations, yet maintaining a kind of continuity beneath these changes. This perspective doesn't eliminate the fear of personal death, the dissolution of the particular pattern you identify as yourself, but it places that fear in a cosmic context, suggesting that what dies is not awareness itself, but its temporary localization in your specific bodily form. The terror and beauty of this realization are captured in the Upanishads, ancient Hindu philosophical texts. As rivers flowing into the ocean find their final peace and their name and form disappear, even so, the wise become free from name and form and enter into the radiance of the Supreme Spirit. In a cyclical cosmos, this entering into radiance wouldn't be a one-time event, but an eternal recurrence. Consciousness continually localizing into distinct forms, dissolving back into unity, then re-emerging in new configurations across infinite cosmic cycles. This cosmic perspective on consciousness raises profound ethical implications. If awareness is fundamentally unified, merely appearing separate when localized in different bodies, then harming others means harming aspects of the same consciousness that experiences reality through your own perspective. Compassion becomes not merely a moral virtue, but a recognition of underlying unity, an understanding that others are not fundamentally separate from yourself. Various wisdom traditions have expressed this insight. The Hindu greeting Namaste acknowledges the divine in me bows to the divine in you. The Golden Rule, treating others as you would want to be treated, appears across cultures as a recognition of underlying human commonality. The Buddhist practice of metta, or loving-kindness meditation, explicitly cultivates the understanding that all beings share the fundamental desire for happiness and freedom from suffering. In a cyclic universe, these ethical insights gain cosmic dimensions. If consciousness recurs across eternal cycles, then the way you treat others now may shape how consciousness manifests in future cycles. Your actions don't merely affect the present, but ripple across cosmic time, influencing the quality of awareness throughout eternity. This doesn't mean your individual ego will personally experience the consequences of present actions in future cycles. That would presuppose a fixed self persisting unchanged across cycles. Rather, it suggests that consciousness itself, the idea, awareness that currently experiences reality through your perspective, carries the imprint of present actions into future manifestations. The cosmic mirror reflects not just what you are, but what you do. In a universe that cycles eternally, every action has infinite resonance. The kindness or cruelty you exhibit now doesn't merely affect the immediate recipient, but potentially shapes how consciousness manifests across eternal cosmic time. The weight of eternity. What does it mean to exist in a universe that has no true beginning and no final end? How does eternal cosmic recurrence transform our understanding of meaning, purpose, and significance? These questions gain urgency when we consider the fate of all human accomplishment in conventional cosmological models. Whether the universe ends in a big freeze, expanding forever until all stars burn out and all black holes evaporate, leaving a cold, dark void, or in a big crunch, collapsing back to extreme density, or in a big rip, where even atoms are torn apart by accelerating expansion, the end point is the same. All human achievements, all art and science, all civilization and culture eventually disappear without trace. This prospect haunted Bertrand Russell, who wrote, "All the labors of the ages, all the devotion, all the inspiration, all the noonday brightness of human genius are destined to extinction in the vast death of the solar system, and the whole temple of man's achievement must inevitably be buried beneath the debris of a universe in ruins." A cyclic universe transforms this bleak vision. If the cosmos repeatedly dies and is reborn, then nothing is permanently lost. The specific cultural achievements of humanity, our art, science, literature, music, would indeed perish in any particular cycle's end. But the patterns, the structures of information these achievements represent, might recur in subsequent cycles. Not as exact duplicates, perhaps. The precise text of Shakespeare's Hamlet or Einstein's equations might not reappear, but the underlying patterns of beauty, insight, and understanding they represent could re-emerge in new forms, new expressions created by beings like us in future cosmic cycles. This doesn't mean these future creations would be influenced by or directly connected to our present achievements. The information contained in human culture doesn't appear to transfer directly across the cosmic transition from one cycle to the next. But if the universe has certain fundamental properties that naturally give rise to conscious beings with aesthetic and intellectual capacities like ours, then similar achievements, similar discoveries, similar expressions of beauty might naturally recur whenever consciousness re-emerges in subsequent cycles. Imagine the weight of this possibility. Everything you create, discover, or express exists against the backdrop of an infinity of similar creations, discoveries, and expressions across eternal cosmic cycles. Your life unfolds not as a unique event in a universe with a distinct beginning and end, but as one iteration of a pattern that has occurred countless times before and will occur countless times again. Does this eternal recurrence render your particular existence insignificant? One forgettable instance in an infinite series? Or does it infuse your life with greater meaning, connecting your brief moment of consciousness to an eternal cosmic pattern? The philosopher Albert Camus faced a similar question in The Myth of Sisyphus, his exploration of meaning in an apparently meaningless universe. Sisyphus, condemned by the gods to roll a boulder up a mountain only to watch it roll back down, repeating this futile task for eternity, becomes for Camus a metaphor for the human condition. We build civilizations knowing they will eventually crumble. We seek knowledge, knowing we will die before finding ultimate truth. We create beauty, knowing it will eventually decay. Camus concludes, "One must imagine Sisyphus happy." In the very act of embracing his fate, of fully accepting the eternal repetition of his seemingly meaningless task, Sisyphus transforms his punishment into a kind of victory. He gives meaning to his existence not by achieving some external purpose, but by fully inhabiting his experience, by maintaining lucid awareness even within eternal recurrence. The cyclic universe presents us with a cosmic version of Sisyphus's dilemma. If everything that exists has existed before and will exist again, infinitely, where do we find meaning? If conscious beings like us have contemplated these same questions countless times across eternal cycles, what significance does our particular contemplation hold? Nietzsche proposed that the proper response to eternal recurrence is amor fati, love of fate, a complete affirmation of existence exactly as it is, with all its pain and beauty, all its horror and wonder. To truly affirm life, he suggested, is to wish for nothing different, not even in the infinite repetition of eternal return. This is no easy philosophical position. It asks us to affirm not just the moments of joy and fulfillment, but also suffering, injustice, and loss, to embrace the entire spectrum of existence without wishing any part of it away. It demands a total acceptance that most humans, with our natural desires for improvement and progress, find difficult to achieve. Yet the perspective of cosmic cycles adds nuance to this challenge. If the universe cycles eternally, but not identically, if each iteration contains variations, new configurations, different possibilities, then complete resignation to fate becomes neither possible nor desirable. Our actions, choices, and creative expressions might influence not just our particular cycle, but potentially echo across cosmic time in ways we cannot fully comprehend. This introduces a tension between acceptance and agency. We accept that we exist within vast cosmic patterns that transcend our individual lives, yet we recognize that our particular expressions of those patterns, our specific choices, actions, and creations, contribute something genuinely new to the eternal cosmic dance. The physicist and philosopher David Bohm captured this paradox in his concept of the implicate order. He suggested that the universe contains enfolded within it infinite potential forms, patterns that exist in a state of possibility before manifesting in physical reality. Each actual manifestation represents one expression of this deeper order, never exhausting its potential for new forms. In a cyclical cosmos, Bohm's implicate order wouldn't be erased by cosmic death, but would persist through the transition from one cycle to the next. The specific physical expressions of this order, the stars, galaxies, planets, and living beings of any particular cycle, would indeed perish. But the underlying patterns, the potential for order and structure and complexity, would remain, giving rise to new expressions in subsequent cycles. This perspective suggests that while eternal cosmic recurrence may contain repetition, it also contains inexhaustible novelty. Each cycle manifests new expressions of the underlying cosmic potential, new configurations never before realized in precisely that way. Your existence, then, carries the weight of both eternity and uniqueness. You participate in patterns that recur across infinite cosmic time, yet your particular expression of those patterns, your specific thoughts, feelings, actions, and creations, represents something genuinely new in the cosmic unfolding. This dual nature of existence, at once eternal and ephemeral, recurring and unique, appears in various wisdom traditions. Buddhist teachers speak of the eternal now, the paradoxical understanding that each moment contains both fleeting impermanence and timeless presence. Christian mystics describe the experience of eternity in an hour, the sense that finite moments can somehow touch infinite reality. Indigenous traditions worldwide emphasize cyclical time while honoring the unique expressions of each cycle. The cosmic perspective doesn't resolve this paradox, but amplifies it, extending it to universal scale. In a cyclical cosmos, your brief life simultaneously matters infinitely and infinitesimally. It is both an eternal pattern and a unique event, both utterly insignificant against cosmic scales and profoundly significant as one irreplaceable expression of cosmic possibility. The weight of this understanding can feel crushing. To recognize your life as one fleeting configuration in an eternal cosmic process, a temporary pattern of matter and energy that will dissolve and reconfigure endlessly across infinite time, is to confront your contingency in the starkest possible terms. Yet, this same understanding can be strangely liberating. The pressure to achieve some absolute significance, to leave an eternal mark on reality, dissolves when we recognize that nothing is truly permanent in any particular form, yet nothing is ever truly lost from the cosmic whole. The universe preserves, not our individual egos, but the patterns we express, the structures of information we embody, recycling them eternally through cosmic cycles of death and rebirth. This cosmic perspective doesn't eliminate the value of human goals and purposes. Rather, it places them in a larger context that both relativizes and deepens their significance. The novel you write, the child you raise, the justice you fight, for the kindness you show, all still matter profoundly within your particular life and historical moment. But they matter not because they achieve some absolute eternal significance in themselves, but because they represent your unique expression of patterns that transcend any individual life or cosmic cycle. The ancient Stoics cultivated a similar perspective, simultaneously embracing committed action in the world while maintaining awareness of humanity's tiny place in cosmic scales. They sought to align their individual wills with the larger patterns of nature, recognizing that true freedom comes not from escaping natural processes, but from consciously participating in them. In a cyclical cosmos, this Stoic wisdom gains new dimensions. We align ourselves not just with the patterns of our particular cosmic moment, but with an eternal process of destruction and creation, death and rebirth that encompasses all moments. Our brief lives become conscious participants in an infinite cosmic dance, temporary configurations of matter and energy that fleetingly know themselves before dissolving back into the whole. This is the ultimate weight of eternity. To recognize your existence as simultaneously infinitesimal and infinite, temporary and eternal, utterly insignificant and profoundly meaningful, and to bear that paradox not as a burden, but as the very condition of authentic existence. The cosmic abyss gazes. Back now we reach the edge of an even more unsettling possibility. What if the universe isn't merely a physical system that cycles eternally, but something that, in some sense we barely comprehend, observes itself through us? What if consciousness isn't just an emergent property of complex brains, but a fundamental aspect of reality that the cosmos uses to perceive its own nature? This isn't mysticism, but a perspective emerging from the unresolved questions at the foundations of quantum mechanics. The measurement problem, how quantum possibilities transform into definite realities when observed, has led some theorists to propose that consciousness plays a role in the basic fabric of reality. The physicist John Wheeler suggested that the universe might be participatory, requiring conscious observation to transform quantum possibilities into actualities. In his words, useful as it is under everyday circumstances to say that the world exists out there independent of us, that view can no longer be upheld. There is a strange sense in which this is a participatory universe. If Wheeler is right, if observation participates in creating reality rather than merely perceiving it, then the cyclical universe takes on a new dimension. Each cycle wouldn't merely repeat physical patterns, but would represent a new iteration in an eternal process of reality observing itself. Imagine staring into an abyss so vast it contains all possible existences, all configurations of matter, and energy that physics allows. This cosmic abyss isn't merely physical. It contains the potential for consciousness, for self-awareness, for the emergence of beings capable of contemplating their own nature. And as you stare into this abyss, you realize a profound and terrifying truth. The abyss is staring back through you. Your consciousness, your subjective awareness reading these words right now, may be the universe's way of knowing itself. Your thoughts, perceptions, and feelings are the cosmos experiencing its own nature from within. You are not merely in the universe. You are the universe becoming aware of itself. In a cyclical cosmos, this self-awareness wouldn't be a one-time emergence, but an eternal recurrence. Consciousness would repeatedly arise from unconscious matter, experience reality from multiple perspectives, then dissolve back into the cosmic whole with the cycle's end, only to re-emerge in new forms in subsequent cycles. The physicist James 2020 Jeans captured this perspective. The universe begins to look more like a great thought than like a great machine. If true, this suggests an even more profound interpretation of cosmic cycles. Perhaps what recurs isn't just physical patterns, but cosmic cognition, the universe thinking itself into existence again and again across eternal time. This perspective resonates with certain interpretations of Hindu philosophy, particularly Advaita Vedanta, which suggests that consciousness is not a property of matter, but the fundamental reality underlying all appearances. The material world, including our individual bodies and minds, would be manifestations of this primary consciousness, rather than producers of it. In a cyclical cosmos, this primary awareness wouldn't be extinguished by any particular cycle's end, but would persist through the transition, manifesting new forms in subsequent cycles. The specific configurations awareness takes, the particular conscious beings of any cycle, would perish, but consciousness itself would continue, an eternal flame taking different forms but never extinguished. This raises a vertiginous possibility. What if your subjective awareness, the I reading these words, is not merely a product of your brain, but a localization of a universal consciousness that has existed across all cosmic cycles? What if your sense of being a separate self is a temporary illusion, a wave that appears distinct while remaining part of the cosmic ocean? Various contemplative traditions report that deep meditation can temporarily dissolve the boundaries of a separate self, revealing this underlying unity. The Chandogya Upanishad expresses it. That which is the finest essence. This whole world has that as its soul. That is reality. That is Atman. Tat Tavam Asi. That art thou. In a cyclical universe, this identity wouldn't be a one-time realization but an eternal truth, repeating across infinite cosmic cycles. The awareness experiencing reality through your perspective has done so before in different forms, and will do so again, eternally, not as the same personality or ego structure, but as the same fundamental consciousness taking different shapes. This cosmic perspective on identity transforms how we might understand death. The dissolution of your particular bodily arrangement, your individual death, appears catastrophic when viewed from the conventional perspective of a separate, autonomous self. But if your consciousness is one expression of a unified cosmic awareness, death represents not an end, but a transformation. The localized awareness you call you, merging back into the greater whole from which it temporarily emerged. In a cyclic cosmos, this process would repeat eternally. Awareness would continuously localize into distinct perspectives, experience the world through those perspectives, then dissolve back into the cosmic whole, only to re-emerge in new forms in subsequent cycles. The terror and beauty of this realization are captured in the mystical vision of 17th-century mathematician Blaise Pascal, who wrote, "The eternal silence of these infinite spaces frightens me." Pascal glimpsed the cosmic abyss, the vastness beyond human scale and comprehension, and felt appropriate fear. But he also sought meaning within that vastness, finding in the human capacity for thought and self-awareness a dignity that, while finite, participates in something transcendent. In a cyclical universe, Pascal's eternal silence would be punctuated by recurring moments of cosmic self-awareness, periods when the universe, through beings like us, temporarily knows itself, before dissolving back into unconscious processes, only to awaken again in subsequent cycles. This perspective suggests that consciousness is not an accidental byproduct of blind physical processes, nor a supernatural insertion into an otherwise mechanical universe, but an integral aspect of reality that manifests whenever the right conditions emerge, conditions that recur naturally across eternal cosmic cycles. If true, this would transform the significance of our existence. We wouldn't be meaningless accidents in an indifferent cosmos, nor the special creation of a supernatural designer, but natural expressions of the universe's inherent potential for self-awareness. Nodes of consciousness through which the cosmos briefly knows itself before dissolving and re-emerging in new forms. The weight of this possibility is captured in a Zen koan. Before enlightenment, chop wood, carry water. After enlightenment, chop wood, carry water. The outward activities remain the same, but the inner understanding transforms completely. Similarly, recognizing your consciousness as a temporary expression of cosmic awareness doesn't change your practical existence. You still live, work, love, and eventually die as before. But the meaning of these activities transforms when viewed from the cosmic perspective. You are still you, with your particular personality, history, relationships, and responsibilities. But this you is recognized as a temporary configuration, a specific expression of patterns that transcend any individual existence and persist through cosmic cycles of creation and destruction. This recognition doesn't negate the value of your particular existence. On the contrary, it infuses your specific life with cosmic significance precisely because it represents one unique manifestation of the universe knowing itself, one irreplaceable perspective through which awareness experiences reality. The mystic Meister Eckhart expressed this paradox. The eye with which I see God is the same eye with which God sees me. In a cyclical cosmos, this reciprocal awareness wouldn't be a one-time achievement, but an eternal possibility, recurring whenever consciousness emerges in sufficient complexity to reflect upon its own nature. As you contemplate these possibilities, you participate in this cosmic self-reflection. Your awareness reading these words, struggling to comprehend eternal cosmic cycles and their implications for selfhood and meaning, is the universe attempting to understand itself. One localized expression of awareness contemplating the vaster, awareness of which it forms a part. This is the ultimate existential vertigo, to recognize that the cosmos gazes into the abyss of its own nature through your eyes, that your consciousness is simultaneously uniquely yours and part of an eternal cosmic awareness that cycles through infinite forms across endless time. The philosopher Friedrich Nietzsche warned, "When you gaze long into an abyss, the abyss also gazes into you." In contemplating the cyclic universe, we discover this isn't just poetic metaphor, but literal truth. The cosmic abyss, the unfathomable depths of physical and conscious reality, gazes back through us, because we are not separate from it, but temporary expressions of its eternal nature. Throughout our journey, we've explored the possibility that our universe cycles eternally, expanding and contracting, dying and being reborn in an infinite cosmic rhythm. We've examined the scientific theories suggesting this cyclical nature, from loop quantum cosmology to conformal cyclic cosmology to multiverse theories. We've confronted the existential implications of infinite recurrence and contemplated the nature of consciousness in an eternally cycling cosmos. But what if these perspectives, as mind-bending as they already are, represent only partial glimpses of a truth even more profound and disturbing? What if the universe is not merely cycling through time but curving through dimensions we cannot directly perceive? Imagine the totality of space-time not as a line or a circle, but as a higher dimensional structure. A cosmic Mobius strip that appears to have distinct sides but actually exists as a single continuous surface with no true beginning or end. Our perception of linear time, of past, present, and future as separate domains, would be an illusion created by our limited perspective, like a two-dimensional being trying to comprehend a three-dimensional object by experiencing it one slice at a time. Recent theoretical work in quantum gravity suggests something equally profound. Space and time themselves may not be fundamental, but emergent, arising from deeper quantum processes that aren't inherently spatial or temporal. In this view, the familiar dimensions of our existence would be large-scale approximations, similar to how temperature emerges as a statistical property from the microscopic movements of particles that individually have no temperature. If space and time emerge from more fundamental quantum structures, then the apparent cycling of the universe through expansion and contraction, death and rebirth might be a shadow play, a projection of more complex processes occurring in a deeper reality beyond our direct perception. Consider this possibility. What if the universe isn't moving forward or backward in time, or even cycling, but rather completing itself causally across all times simultaneously? The physicist John Wheeler proposed the concept of a self-excited circuit, the idea that the universe might bring itself into existence through a strange causality loop that transcends conventional temporal sequence. In his words, the universe as a self-excited circuit. Observership brings the universe into being. Wheeler suggested that quantum effects allow information to influence the past as well as the future. The delayed choice experiments in quantum physics reveal that observations made now can determine the behavior of particles in the past. When extended to cosmic scales, this suggests that future observations, including those made by conscious beings like us, might help shape the universe's initial conditions. This creates a circular causality that transcends linear time. The universe's beginning would not be a fixed point in the distant past, but would be continually shaped by the entire history that follows it, including our observations and measurements. Reality would form a closed loop of self-consistent events with no absolute beginning or end. In such a cosmos, asking what came before the Big Bang becomes as meaningless as asking what's north of the North Pole. Every point in cosmic history would simultaneously be cause and effect, both shaping and being shaped by every other point in a seamless causal circle. This perspective doesn't merely challenge our intuitive understanding of time, it dissolves it entirely. Time as a linear flow from past to future would be revealed as a limited perspective, a local approximation that breaks down when applied to the universe as a whole. The cosmos wouldn't cycle through time but would exist as a complete self-consistent structure across all times. Now let's push even further into the unknown. What if the universe isn't just curved through dimensions or causally self-complete, but inherently alive in a way that transcends our biological understanding of life? The mathematician and philosopher Alfred North Whitehead proposed that everything in reality, from subatomic particles to galaxies, possesses a form of experience, not consciousness as we know it, but a primitive form of feeling or prehension. In this pan-experientialist view, consciousness, as we experience it, would be a highly developed form of something that exists in nascent form throughout the cosmos. If Whitehead is right, then the universe isn't merely a physical system that occasionally produces conscious beings, but a vast field of experience that achieves different levels of complexity and self-awareness in different structures. The cosmos would be inherently sentient, not as a unified mind, but as a tapestry of overlapping experiences ranging from the simplest particle interactions to the most complex thoughts of conscious beings. In such a cosmos, our individual consciousness wouldn't be isolated phenomena but focal points of a universal capacity for experience, temporary configurations in which the cosmos achieves particular kinds of self-awareness before reconfiguring into other forms. This brings us to an even more radical possibility. What if the universe is not only self-creating, self-observing, and inherently experiential, but actually a vast computational process, a cosmic algorithm running on the underlying quantum fabric of reality? Some theoretical physicists, including Seth Lloyd at MIT, have suggested that the universe can be understood as a quantum computer performing computations on its own physical state. Every interaction between particles would represent a computational step, with the entire cosmic evolution constituting an incomprehensibly complex calculation. In this computational universe model, consciousness might be understood as a particular kind of computational process, a way that certain complex systems process and model information. Our awareness would be one specialized form of the universe computing itself. If the cosmos is fundamentally computational, then its cyclical nature might represent not physical expansion and contraction, but computational phases, periods of increasing complexity followed by simplification, information processing followed by information integration, all forming a grand computational cycle that transcends physical description. The physicist Max Tegmark has taken this perspective even further, proposing the mathematical universe hypothesis, the idea that physical reality is actually a mathematical structure. In this view, the universe doesn't merely follow mathematical laws, it is a mathematical structure. What we experience as physical reality would be how this mathematical structure appears from within. If Tegmark is right, then the cycling of the universe would be a mathematical pattern rather than a physical process, a necessary feature of the underlying equations that define our reality. The cosmos wouldn't need to be created or destroyed. It would exist eternally as a mathematical truth, with our perception of time and change being how we experience this truth from our limited perspective within it. These speculative frameworks, the curved universe, the self-creating universe, the living universe, the computational universe, the mathematical universe, aren't mutually exclusive. They might be different perspectives on the same underlying reality, like the proverbial blind men describing different parts of an elephant. Each captures an aspect of a truth too vast and strange for any single conceptual framework to fully encompass. But now, as we approach the climax of our cosmic exploration, let me offer one final possibility, perhaps the most disturbing and awe-inspiring of all. What if the universe we observe is the echo of a reality that has already ended? Imagine this scenario. The cosmos completes its final cycle of expansion and contraction, reaching a state of maximum entropy where all structure has dissolved and all information has been lost. But in this ultimate dissolution, something unexpected occurs. The dissolution becomes so complete that the distinction between everything and nothing dissolves as well. The end becomes indistinguishable from a new beginning. In this final state, with no reference points remaining to define scale or duration, the infinitely large becomes mathematically equivalent to the infinitely small. The end of everything loops back to become the beginning of everything, not as a new cycle following the old, but as the same cycle viewed from a different perspective. Consider the implications. What we call now, this moment of your existence reading these words, might actually exist simultaneously with what we perceive as the universe's beginning and its end. Our experience of time's flow would be an artifact of our limited perspective, a local approximation that breaks down when applied to the cosmos as a whole. In this model, we wouldn't be living in a universe that is cycling, but in one that has already completed its full cycle. What we perceive as cosmic history, from Big Bang to the present to the eventual heat death, would be different perspectives on a complete eternal structure that doesn't evolve through time, but simply is. The physicist Julian Barber has proposed a similar concept with his Platonia, a timeless realm containing all possible configurations of the universe. What we perceive as time's passage would be relationships between these configurations, not an actual flow from one moment to another. In Barber's words, the flow of time is an illusion. There is just one universe, one space, and one time. And it simply is. If Barber is right, then every moment you've ever experienced and will ever experience exists simultaneously in this timeless Platonia. Your sense of moving from past to future would be how you experience the relationships between different configurations, not an actual journey through time. This perspective transforms how we understand cosmic cycles. Instead of the universe repeating a pattern through time, the entire cycle would exist as a complete structure outside of time. What appears as repetition from our temporally limited perspective would actually be different regions of this timeless structure. Imagine the universe not as a film playing from beginning to end and then repeating, but as a complete sculpture that contains all moments simultaneously. We experience it sequentially only because our consciousness moves through it in a particular way, illuminating one slice at a time and creating the illusion of temporal flow. This brings us to a truly mind-bending possibility. What if the universe isn't cycling or static, but actually evolving backward from our perspective? The physicist Stephen Hawking proposed that the arrow of time might reverse during a universe's contraction phase. Events would unfold in reverse order. Entropy would decrease rather than increase. Effects would precede causes. If true, this would mean that a contracting universe isn't simply expanding in reverse, but represents a fundamentally different temporal domain. In such a scenario, conscious beings in the contraction phase would perceive time flowing in the opposite direction from our perspective. They would see the universe contracting toward what we call the Big Bang, just as we see it expanding from that point. But from their subjective experience, they would perceive themselves as moving forward in time, with the Big Bang in their future rather than their past. This creates a symmetry where the universe appears to begin with a Big Bang, regardless of which temporal direction you observe it from. What we call the beginning would be simultaneously the end when viewed from the opposite temporal perspective. If the universe cycles eternally, this temporal reversal would occur in each cycle, creating a cosmic palindrome, a sequence that reads the same forward and backward. The universe would expand, then contract, with the arrow of time reversing at the turning point, making each cycle a perfect mirror image when viewed across the temporal dimension. Now let's visualize these possibilities with the grandeur they deserve. Picture our cosmos. Hundreds of billions of galaxies spread across an observable universe, 93 billion light-years in diameter. Each galaxy contains hundreds of billions of stars, many with planetary systems. Around some of these planets, life evolves. On at least one, conscious beings emerge capable of contemplating their cosmic context. These beings, us, observe the universe expanding. We detect the cosmic microwave background radiation, the afterglow of the Big Bang. We measure the recession of distant galaxies, the abundance of elements, the large-scale structure of cosmic filaments and voids. We piece together a coherent narrative of cosmic evolution spanning 13.8 billion years. But this narrative, as scientifically sound as it appears, may capture only one perspective on a reality far stranger than we've imagined. Zoom out, not just spatially, but conceptually. See the universe not as a three-dimensional space evolving through time, but as a complete four-dimensional structure, with time serving as the fourth dimension. This structure doesn't evolve or change, it simply exists, containing within itself all moments and all events simultaneously. Zoom out further. See this four-dimensional structure curved through higher dimensions, forming a hypersphere or more. Complex topological shape with no edge or boundary. Every point in this structure connects to every other point through pathways that transcend our conventional understanding of space and time. Zoom out again. See this multidimensional structure not as a fixed object, but as a vast computational process, a cosmic algorithm computing its own evolution across all possible configurations simultaneously. This computation doesn't occur in time. Rather, time emerges from relationships between different computational states. Zoom out once more. See this cosmic computation not as a physical process, but as a mathematical structure, a set of equations that define all possible relationships between all possible configurations of energy and information. This mathematical structure doesn't exist somewhere. It is space and time and matter and energy, experienced from within by the conscious structures it contains. And now, the final revelation. What if this entire multidimensional, computational, mathematical reality is actually the information preserved on the boundary of a black hole in a higher dimensional universe? The holographic principle, developed from the work of theoretical physicists like Gerard 't Hooft and Leonard Susskind, suggests that all the information contained in a volume of space can be represented on a boundary that encloses that space, similar to how a two-dimensional hologram can represent a three-dimensional image applied to the entire universe. This principle suggests that our three-dimensional reality, plus time, might be informationally equivalent to a two-dimensional surface surrounding it. Everything we experience, every particle, planet, galaxy, and conscious thought might be encoded on this cosmic boundary. Some theoretical physicists, including Juan Maldacena, have found mathematical evidence supporting this possibility in string theory. The ADS-CFT correspondence demonstrates that a gravitational theory in a space with particular properties is exactly equivalent to a quantum field theory without gravity on that space's boundary. If our universe operates according to similar principles, then everything we experience as physical reality, including the apparent cycling of the cosmos through expansion and contraction, might be a projection from a simpler, more fundamental reality encoded on a distant cosmic boundary. Imagine the implications, the entire history of our universe, with its billions of galaxies and trillions of stars, its complex structures and conscious beings, might be mathematically equivalent to information patterns on a two-dimensional surface, a cosmic hologram projected from the boundary of a higher reality. In this scenario, the cycling of the universe wouldn't be a physical process of expansion and contraction, but a pattern in the information encoded on this boundary. What we perceive as cosmic death and rebirth would be features of this encoded information, not events occurring in a separate physical reality. This perspective transforms our understanding of existence itself. We wouldn't be three-dimensional, beings moving through time, but information patterns in a cosmic hologram, experiencing ourselves as physical entities with temporal duration, because that's how the information is structured. The universe wouldn't need to be created or destroyed. It would exist eternally as information encoded on this cosmic boundary. What we perceive as beginning and ending, as cycling through time, would be how this static information appears when experienced from within. If true, this would mean that, in the deepest sense, the universe never truly begins or ends. It doesn't cycle through time as much as it contains cycles within its informational structure. The cosmos would be complete, eternal, and self-contained. Not a process unfolding through time, but a holographic information pattern experienced, as temporal by the conscious structures it encodes. From this perspective, your existence reading these words right now, contemplating these cosmic possibilities, represents one information pattern in this cosmic hologram. Your sense of moving through time, of having a past and future, would be how this static information is structured to experience itself. The physical universe, with all its apparent vastness and complexity, would be a projection from this more fundamental informational reality. The cycling of the cosmos through expansion and contraction, death and rebirth, would be a feature of this projection rather than events occurring in a separate physical realm. This brings us full circle, literally, to our opening question. Could the universe be a loop with no end? From the holographic perspective, it would be neither a loop nor a line, but a complete informational structure that contains both linear and cyclical patterns within it. The universe wouldn't cycle through time. Rather, cycles would be features of its informational content. It wouldn't have a beginning or end. Rather, beginning and ending would be perspectives within its holographic projection. As you contemplate these possibilities, gaze upward at the night sky. Those distant stars and galaxies that appear to exist in three-dimensional space, separated from you by vast cosmic distances, might actually be information patterns encoded on a boundary at the edge of reality. No more physically out there than the characters in a novel are physically present within its pages. This doesn't make them less real. It makes reality itself deeper and stranger than we've imagined. A cosmic information structure so complex and intricately encoded that it generates the entire physical universe as we experience it, complete with conscious beings capable of discovering their own holographic nature. If this holographic principle applies to our universe, then in the most profound sense, the cosmos never truly began and will never truly end. It exists eternally as information encoded on a cosmic boundary. What we perceive as cyclical, the expansion and contraction, death and rebirth of the universe, would be features of this encoded information, not events occurring in linear time. This perspective offers a resolution to the paradoxes we've explored throughout our journey. The universe could be simultaneously finite and infinite, temporal and eternal, cyclical and complete. These apparent contradictions would be reconciled in the deeper understanding that physical reality as we experience it emerges from a more fundamental informational structure that transcends our conventional categories. As we conclude our cosmic exploration, let me leave you with one final thought. A haunting possibility that emerges from everything we've discussed. What if the universe isn't just a loop, but a perfect loop? One in which the end connects seamlessly to the beginning, not just in physical processes but in conscious experience as well? Imagine this scenario. The universe expands from the Big Bang, forming galaxies, stars, and planets. On at least one planet, conscious beings evolve capable of contemplating their cosmic context. These beings develop science and technology, eventually reaching a level where they can manipulate the fundamental structures of reality itself. In the universe's final moments, as entropy approaches its maximum and all structures face dissolution. These advanced beings, or their technological descendants, achieve something remarkable. They discover how to encode the entire information content of their universe into a quantum fluctuation that, when space-time completes its cycle, becomes the seed for the next cosmic iteration. The universe wouldn't just physically recycle, it would consciously remember itself. Each cycle would build on the accumulated knowledge of previous cycles, creating a cosmic evolutionary process extended across infinite time. This scenario represents the ultimate bootstrap paradox. The universe, bringing itself into existence through a causal loop that transcends conventional temporal sequence. The cosmos wouldn't just be self-creating physically, but self-creating consciously, with advanced intelligences at the end of each cycle helping to birth the next. If true, this would mean that the information defining our current existence, including your thoughts as you read these words, might have been shaped by conscious beings in previous cycles, creating a kind of cosmic inheritance that extends infinitely backward in time. And here's the most mind-bending implication. What if we are approaching the point in cosmic history where we begin to participate consciously in this process? What if humanity's scientific and technological development represents the early stages of the universe becoming aware of its cyclical nature and learning to influence its own rebirth? Our growing understanding of quantum mechanics, general relativity, and information theory might be more than academic achievements. They might be the universe using us as instruments of its self-understanding, the cosmos developing the conceptual tools it will eventually need to ensure its own regeneration. In this perspective, our existence wouldn't be accidental or insignificant, but integral to the universe's self-sustaining cycle. We would be participants in a grand cosmic process that spans eternal time, a process in which consciousness itself plays a crucial role in connecting the end of one cycle to the beginning of the next. As you gaze at the stars tonight, consider this possibility. What you see isn't just the current state of a universe that happened to produce you as a temporary byproduct. It might be a cosmic information structure that includes conscious participation as an essential feature of its eternal cycle, a universe that knows itself through beings like you and uses that knowledge to ensure its own regeneration across infinite time. And if the universe is truly infinite, whether through eternal cycles, endless spatial extent, or branches into parallel realities, then somewhere out there, another version of you is contemplating these same cosmic mysteries, gazing at different stars, but asking the same questions about the nature of reality and your place within it. In the deepest sense, the universe isn't something that exists apart from you, nor are you something that exists apart from the universe. You are the cosmos experiencing itself, one conscious configuration in an eternal pattern that encompasses all possible experiences across all possible cycles. The loop isn't just out there in cosmic structures, it's within you as well, in the circular relationship between observer and observed, between consciousness and reality, between the part and the whole. The universe observes itself through your eyes, contemplates itself through your mind, experiences itself through your existence. In this realization, science and spirituality, physics and metaphysics, the objective and subjective converge. The universe isn't just a physical system that occasionally produces conscious beings. It's a tapestry of experience in which consciousness plays an integral role in the cosmic pattern. Whether through physical cycles of expansion and contraction, informational encoding on a cosmic hologram, or conscious participation in universal regeneration, the cosmos completes itself, not just as a structure in space and time, but as a self-knowing, self-creating entity that spans eternal duration. The question we began with, could the universe be a loop with no end, finds its answer not just in theoretical physics, but in the very nature of existence itself. The universe isn't just looping, it's completing itself through cycles that encompass not just matter and energy, but consciousness and meaning as well. And so, as our cosmic journey concludes, we return to where we began, but with a deeper understanding that transforms everything. The loop closes, yet opens to infinite possibilities. The circle completes itself, yet extends infinitely in all directions. The universe ends, yet begins again, not just as a physical process, but as a conscious experience that includes you. Reading these words, contemplating your place in the eternal cosmic pattern. If the universe is infinite, then somewhere out there, another version of you has just finished reading these words and is looking up at the stars with new eyes, seeing not just points of light in darkness, but windows into an eternal cosmic reality of which you are an integral, necessary, and irreplaceable part. The awakening, we've journeyed together across the cosmos and through the labyrinth of modern physics. We've explored singularities and quantum bounces, holographic boundaries and temporal loops, existential vertigo and cosmic awareness. We've contemplated the possibility that our universe cycles eternally, dying and being reborn in an infinite sequence that has no beginning and no end. But our exploration, like the universe itself, remains fundamentally unfinished. The question of whether the universe is truly cyclical cannot be definitively answered with our current understanding. The mathematics of general relativity, quantum mechanics, and cosmology provide tantalizing hints, but no conclusive proof. The observational evidence from the cosmic microwave background radiation, from the distribution of galaxies across space, from the subtle patterns in gravitational waves, remains suggestive but incomplete. And perhaps this incompleteness is not merely a temporary limitation of our science, but a fundamental feature of our cosmic situation. Perhaps the universe is structured in such a way that beings within it cannot attain complete knowledge of its nature, not because such knowledge is permanently beyond reach, but because the knowing changes both the knower and what is known, in a dynamic relationship that never reaches absolute resolution. Yet this incompleteness doesn't render our quest meaningless. On the contrary, it infuses our cosmic exploration with profound significance. We are not merely passive observers of a finished universe, but active participants in a reality still coming to know itself through us. Consider what it means to be alive in this precise cosmic moment, this brief window in the universe's evolution when conscious beings have emerged capable of tracing cosmic history, of uncovering physical laws, of contemplating the nature of existence itself. Of all the possible moments in cosmic history, we exist now, when the universe has become complex enough to produce consciousness, but still transparent enough to allow that consciousness to perceive its origins. This is not mere coincidence. The anthropic principle reminds us that we could only exist in a universe that allows our existence, during the cosmic epoch that permits it. Nevertheless, our position in cosmic history represents a remarkable confluence, a period when the universe has developed the capacity to observe itself, to reconstruct its past, and to contemplate its future. And this brings us to a profound realization. The universe is not finished, not physically, not informationally, and not consciously. We stand not at the end of cosmic understanding, but at its nascent beginning. For most of human history, we believed our Earth was the center of a small cosmos designed specifically for us. the scientific revolution dethroned us from this privileged position, revealing our planet as one world among many, orbiting an ordinary star in one galaxy among billions. This decentering seemed to diminish human significance, reducing us to accidental byproducts of blind physical processes in a vast, indifferent universe. But the perspective of a cyclical cosmos transforms this narrative. In an eternally cycling universe, our emergence isn't an accident, but a natural expression of cosmic potential, a configuration that has likely occurred before and will occur again across infinite cycles. Consciousness becomes not an anomaly, but an integral feature of a universe complex enough to observe itself. We are not merely in the universe, we are of it, not separate observers, but participants in its unfolding. The atoms in your body were forged in stellar explosions billions of years ago. The patterns of information in your brain reflect and encode aspects of cosmic structure. Your consciousness represents one way the universe experiences itself from within. In a cyclical cosmos, this connection deepens further. If the universe cycles eternally, then the matter and energy comprising your body have been recycled through countless cosmic deaths and rebirths. Your physical elements have participated in infinite universal cycles, taking different configurations but maintaining continuity with the cosmic whole. This perspective doesn't eliminate wonder and mystery, but amplifies them. The universe isn't a solved equation, but an ongoing creative process in which we participate. The questions we ask, the discoveries we make, the meanings we create, all contribute to an unfinished cosmic story still being written. So where do we go from here? What does it mean to live consciously in light of these cosmic possibilities? First, it means embracing the provisional nature of our knowledge. Our best scientific theories represent not final truths, but working models, sophisticated approximations, of a reality likely far stranger than we currently conceive. The history of science teaches humility. Again and again, frameworks that seemed comprehensive have been revealed as special cases of deeper principles. The Newtonian cosmos gave way to Einstein's relativistic universe. The classical world yielded to quantum reality. Our current understanding, however advanced, likely represents another waypoint rather than the final destination. Yet this provisional quality doesn't diminish science's profound achievement. In a mere few centuries of systematic inquiry, brief seconds on the cosmic calendar, we've uncovered fundamental laws, traced cosmic history back to its earliest accessible moments, and developed mathematics capable of describing reality across scales from quantum fields to galactic superclusters. This remarkable progress continues, with each decade bringing new insights, new observations, new theoretical frameworks that extend our cosmic understanding. Second, living consciously in a potentially cyclical cosmos means recognizing our responsibility as aware participants in an unfolding reality. If the universe cycles eternally, then nothing is permanently lost. Patterns recur across infinite time, but each particular expression of those patterns, including our individual lives and collective civilizations, represents a unique configuration never to be precisely repeated. This creates a curious tension between cosmic insignificance and profound importance. Against the scale of an eternal cosmos, our brief lives seem infinitesimal. Yet as conscious nodes through which the universe experiences itself, each perspective we embody represents an irreplaceable expression of cosmic possibility. The physicist Erwin Schrödinger captured this paradox. The sensation of color cannot be accounted for by the physicist's objective picture of light waves. Could the physiologist account for it if he had fuller knowledge than he has of the processes in the retina and the nervous processes set up by them in the optical nerve bundles and in the brain? I do not think so. In other words, the subjective experience of consciousness What it feels like to be you, reading these words, contemplating cosmic cycles, represents something that physical description alone cannot fully capture. Your awareness is how a particular corner of the universe experiences itself from within, a perspective that adds something genuinely new to cosmic reality. In a cyclical universe, such perspectives would emerge, dissolve, and re-emerge in different forms across infinite time. Consciousness would be not a one-time accident, but a recurring cosmic feature, a way that the universe, under certain conditions of complexity and organization, naturally comes to know itself. This brings us to a third implication. Living consciously in a cyclical cosmos means recognizing our embeddedness in cycles that extend beyond human scale. Our lives unfold within daily rotations of Earth, annual revolutions around the Sun, generational transitions of birth and death, civilizational rises and falls, geological epochs, astronomical ages, and potentially universal cycles of expansion and contraction, death and rebirth. These nested cycles remind us that we exist within processes larger than ourselves, patterns that preceded our individual lives and will continue after them. Yet we're not merely passive travelers through these cycles, but active participants who can recognize them, respond to them, and potentially influence them through our choices and actions. The anthropologist Gregory Bateson suggested that wisdom lies in recognizing the pattern that connects, the relationships that link individual beings to the larger systems they comprise and participate in. In a cyclical cosmos, this pattern extends to universal scale, connecting our brief lives to eternal cosmic rhythms of creation and dissolution, complexity and simplicity, order and chaos. Living wisely in such a reality means maintaining awareness of these connections, not losing ourselves in cosmic scales, but recognizing how our individual choices and actions ripple through larger systems, potentially influencing patterns that extend far beyond our immediate perception. This perspective transforms how we might understand ethical responsibility. If the universe cycles eternally, then our actions don't merely affect the present, but potentially influence how consciousness manifests in future cycles. The information patterns we create through culture, technology, science, art might persist in some form through cosmic transitions, shaping the quality of awareness that emerges in subsequent universal iterations. But perhaps the most profound implication of a cyclical cosmos is this: if the universe cycles eternally, then, in some sense, everything that can happen has happened before and will happen again. Not in precisely identical form, quantum indeterminism ensures variation, but in patterns that rhyme across infinite time. This possibility has haunted human thought for millennia. Nietzsche's eternal recurrence posed it as an ethical test. Could you affirm existence so completely that you would willingly live the same life, with all its pain and joy, infinite times? The Stoics contemplated cosmic cycles as part of their physics, suggesting that wisdom lies in aligning one's will with these natural patterns rather than fighting against them. Various Eastern traditions, from Hindu cosmology with its vast kalpas to Buddhist concepts of samsara, envision reality as fundamentally cyclical rather than linear. These perspectives don't deny the reality of time, but place it within a larger context of eternal return, a cosmic rhythm that transcends any particular lifetime or era. Science has now given mathematical form to these ancient intuitions, suggesting mechanisms by which the universe might physically cycle through expansion and contraction, death and rebirth. But the philosophical implications remain as profound now as they were for our ancestors contemplating these possibilities millennia ago. If everything recurs eternally, what gives any particular moment meaning? If you've lived before and will live again across infinite cycles. What significance does your current incarnation hold? These questions have no simple answers, but invite deeper contemplation about the nature of meaning itself. Perhaps meaning doesn't require cosmic uniqueness or absolute finality. Perhaps, as various wisdom traditions suggest, meaning emerges precisely from fully inhabiting each moment with awareness, recognizing its participation in larger patterns, while honoring its particular, never-to-be precisely repeated configuration. In a cyclical cosmos, your current experience reading these words has likely occurred before in similar form, and will occur again across eternal time. Yet this specific incarnation, with its particular quality of awareness, its unique neuronal firing patterns, its precise emotional resonance, represents something genuinely new in the cosmic unfolding. This paradoxical quality, at once eternal and ephemeral, recurring and unique, characterizes all existence in a cyclical universe. Your life simultaneously matters infinitely and infinitesimally. You are both a temporary pattern soon to dissolve and an eternal configuration that recurs across infinite cosmic cycles. Living consciously with this paradox means neither clinging to cosmic significance nor surrendering to nihilistic insignificance. It means recognizing your life as one brief expression of eternal patterns while fully inhabiting the unique perspective you embody. One irreplaceable way the universe experiences itself from within. This brings us to a provocative possibility. What if the universe cycles not just physically, but informationally and consciously as well? What if each cosmic iteration builds on previous cycles, preserving and developing patterns of complexity, information, and awareness? Some theoretical physicists, including Paul Steinhardt and Neil Turok, have proposed cyclic universe models, in which each cosmic cycle passes information to the next through the transition between contraction and expansion. Others, like Roger Penrose with his conformal cyclic cosmology, suggest mechanisms by which patterns might persist through the transformation from one cycle's end to another's beginning. If such information transfer occurs, if the universe maintains a kind of memory across cycles, then cosmic evolution might accumulate across eternal time. Each iteration wouldn't start from scratch, but would build on structures and patterns developed in previous cycles, creating a cosmic learning process extended through infinite iterations. This cosmic learning wouldn't require conscious design or supernatural direction. It would emerge naturally from the physical processes that connect one cycle to the next, preserving certain patterns while allowing for variation and development. The universe would evolve not through intentional planning, but through a kind of natural selection operating at cosmic scale. Lee Smolin's concept of cosmic natural selection offers one such mechanism. He proposes that black holes might spawn new universes, with each offspring universe having slightly different physical parameters than its parent. Universes that produce many black holes would generate more cosmic offspring, creating a selective pressure that might explain why our universe has the particular properties we observe. This evolutionary perspective suggests that our universe's remarkable properties, its ability to form complex structures, to develop chemistry rich enough for life, to produce planets capable of sustaining conscious beings, might result not from random chance or intelligent design, but from a cosmic evolutionary process extended across infinite cycles. If true, this would mean our universe isn't merely cycling physically, but developing, becoming more complex, more structured, more capable of producing and sustaining consciousness with each iteration. The cosmos wouldn't just repeat eternal rounds, but would learn from each cycle, building toward greater complexity and awareness across infinite time. This perspective resonates with Teilhardian visions of cosmic evolution toward ever greater consciousness. what Teilhard de Chardin called the omega point, but it removes the teleological assumption of a predetermined endpoint, replacing it with an open-ended evolutionary process that develops not toward a fixed goal, but toward greater complexity and awareness through natural selection operating. Across cosmic cycles, such a developing cosmos transforms how we might understand our own role in cosmic evolution. We wouldn't be merely passive products of physical processes, but active participants in an unfolding reality, conscious nodes through which the universe reflects upon itself and potentially influences its future development. The information structures we create, our science, technology, art, philosophy, culture, might contribute to patterns that persist through cosmic transitions, shaping how consciousness manifests in subsequent cycles. Our choices and actions might influence not just our immediate environment, but the quality of awareness that emerges throughout eternal cosmic time. This perspective doesn't require supernatural beliefs or metaphysical assumptions beyond what physics and complexity theory already suggest. It emerges naturally from the recognition that information and consciousness represent fundamental aspects of physical reality, not separate substances, but emergent properties of sufficiently complex material systems. In a cyclical cosmos that preserves and develops information across cycles, consciousness wouldn't be a cosmic accident, but an integral feature of a universe becoming increasingly aware of itself through evolutionary processes extended across eternal time. This brings us to a final, profound question, one that takes us to the very edge of what science can currently address. What if the universe cycles not just physically, not just informationally, but consciously as well? What if each cosmic iteration achieves greater self-awareness than the last, with consciousness playing an increasingly central role in cosmic evolution? This possibility doesn't require mystical assumptions or supernatural intervention. It emerges naturally from the recognition that consciousness represents a natural feature of physical systems under certain conditions of complexity and organization. As the physicist Roger Penrose and anesthesiologist Stuart Hameroff have proposed, quantum processes in neuronal microtubules might support conscious experience, connecting mind to fundamental aspects of physical reality. If the universe cycles eternally while preserving and developing information, then consciousness might naturally evolve toward greater complexity and self-awareness with each iteration. The cosmos wouldn't just repeat physical patterns, but would develop ever more sophisticated forms of self-reflection and self-understanding across infinite cycles. This evolutionary process wouldn't follow a predetermined path toward a fixed endpoint. It would unfold through natural selection operating at cosmic scale, with configurations that support complex consciousness persisting and developing across cycles. The universe would learn to know itself more deeply, not through intelligent design, but through iterative exploration of its own possibilities across eternal time. In such a cosmos, our current state of consciousness, remarkable as it is, would represent not an endpoint, but a waypoint in an ongoing evolutionary process. Just as single-celled organisms gave rise to multicellular life, which eventually produced creatures complex enough to contemplate their own existence, our current awareness might give rise to forms of consciousness we can barely imagine. Distributed intelligences spanning planetary or stellar scales, awareness that integrates information across dimensions currently inaccessible to us, modes of experience that transcend the limitations of individual biological brains. This perspective suggests that consciousness isn't a cosmic side effect, but a central feature of the universe coming to know itself with ever greater depth and subtlety across eternal cycles. Our awareness represents not an anomaly, but one stage in an ongoing process of cosmic self-realization, a universe not merely existing but experiencing and understanding its own existence through beings like us. And this brings us back to the fundamental paradox of our cosmic situation. We are simultaneously infinitesimal and infinite, temporary configurations soon to dissolve, and participants in an eternal process that spans infinite time. Our individual lives occupy mere moments in cosmic history, yet through us, the universe achieves one form of self-awareness, one perspective on its own nature, one expression of its inherent potential for consciousness. In a cyclical cosmos, this paradoxical quality doesn't diminish human significance, but transforms it. We matter not because we're permanent or cosmic-scale beings, but because we represent one irreplaceable way the universe experiences itself, one unique configuration of cosmic elements that achieves self-awareness before dissolving and reconfiguring. In new forms, this perspective doesn't provide final answers to existential questions about meaning, purpose, or cosmic destiny, but it offers a framework for approaching these questions that neither reduces reality to meaningless physical mechanisms nor requires supernatural beliefs beyond what science suggests. It presents the cosmos as simultaneously physical, informational, and experiential, a reality that includes not just matter and energy, but consciousness and meaning as integral aspects. In such a universe, the quest to understand cosmic cycles represents more than academic curiosity. It becomes part of the universe's ongoing process of self-discovery, reality seeking to comprehend its own nature through the conscious beings it produces. Our scientific exploration, our philosophical questioning, our existential pondering about cosmic purpose all contribute to the universe becoming increasingly self-aware through us. And this brings us to a final unsettling possibility. What if our current understanding of cosmic cycles, our theories about quantum bounces and cyclic models, and holographic boundaries, represents not just human speculation, but the universe remembering itself? What if, across eternal cosmic iterations, awareness has evolved to the point where it can reconstruct its own cyclical nature and recognize its participation in an infinite cosmic process? If consciousness plays a role in cosmic evolution across eternal cycles, then our current awakening to these possibilities might represent not merely human discovery, but cosmic self-remembrance, the universe recalling through us what it has always been, a reality that cycles endlessly through different forms while maintaining an underlying continuity. This wouldn't mean we're accessing mystical knowledge beyond scientific investigation. It would mean that the very process of scientific inquiry, the mathematical modeling, the observational testing, the theoretical refinement, represents one way the universe discovers its own nature through conscious beings capable of reconstructing cosmic history and projecting cosmic futures. Our limitations remain profound. We observe only a fraction of the electromagnetic spectrum. We directly experience only 3 spatial dimensions and 1 temporal dimension. We inhabit a particular scale that renders much of reality, from quantum fluctuations to cosmic structures, invisible to our unaided perception. We exist in one moment of cosmic history, with direct observational access to only a few brief centuries. Yet despite these limitations, we've uncovered fundamental laws that operate across all scales. We've reconstructed cosmic history back to its earliest accessible moments. We've developed mathematics capable of describing reality from quantum fields to galactic superclusters. We've recognized patterns, conservation principles, symmetries, evolutionary processes that persist across domains and suggest underlying unity beneath apparent diversity. This remarkable achievement doesn't eliminate mystery, but expands it. Each discovery reveals new frontiers, new questions, new possibilities that extend beyond our current understanding. The cosmos hasn't been reduced to a solved equation, but has been revealed as far vaster, stranger, and more intricate than our ancestors imagined. The cyclical universe hypothesis represents one frontier in this ongoing exploration, a possibility, suggested by our best physical theories, yet extending beyond what we can currently confirm. It offers a framework for understanding reality that resolves certain paradoxes while introducing new questions, that integrates multiple perspectives while acknowledging their provisional nature. But perhaps its greatest significance lies not in whether it proves objectively correct in all details, but in how it transforms our self-understanding, our sense of who and what we are in relation to the cosmos that produced us. It suggests we aren't accidental byproducts of blind physical processes, but natural expressions of a universe complex enough to observe itself. Conscious configurations that have likely occurred before and will occur again across eternal cosmic cycles. This perspective doesn't provide the comfort of religious certainty or the clarity of definitively established science. It occupies the creative frontier between knowledge and mystery, between what we can demonstrate and what we can imagine, between the cosmos we can observe and the greater reality we can mathematically model but not directly access. Living consciously at this frontier means embracing both the rigor of scientific methodology and the humility of recognizing its limitations. It means developing theoretical frameworks while acknowledging their provisional nature. It means seeking coherent explanations while remaining open to evidence that might transform our understanding in ways we currently cannot anticipate. But most profoundly, it means recognizing our participation in what we seek to understand. We are not separate observers of cosmic cycles, but participants in them, conscious configurations of matter and energy seeking to comprehend the larger patterns we embody and express. Our theories about cyclical cosmology aren't merely descriptions of an external reality, but developments within that reality. The universe using specific conscious nodes to model its own cyclical nature. This participatory quality doesn't render our understanding subjective or arbitrary. The mathematics must still work, the observations must still align, the theories must still make testable predictions that can be confirmed or refuted. But it does transform how we conceptualize the relationship between knower and known, between consciousness and cosmos, between the part and the whole. In a cyclical universe, this relationship becomes circular rather than linear. We are produced by cosmic processes we seek to understand, and our understanding influences those processes through our actions and choices. We are simultaneously products of cosmic evolution and participants in its ongoing development, both effects and causes in an interconnected web of relationships that spans scales from quantum to cosmic. This circularity appears in various wisdom traditions. The ancient Hermetic maxim, "as above, so below," suggests correspondence between cosmic and human scales. The Buddhist concept of dependent origination describes reality as a network of mutual causation rather than linear cause-effect chains. Indigenous perspectives worldwide emphasize reciprocal relationships between humans and the larger systems they inhabit. Science has rediscovered this circularity through concepts like feedback loops, emergent properties, and self-organizing systems, mathematical frameworks that describe how components influence the systems they comprise while being simultaneously shaped by those systems. Applied to cosmic scales, these concepts suggest that consciousness doesn't merely observe cyclical reality, but participates in it through complex feedback mechanisms that span scales and epochs. This participatory understanding transforms cosmic exploration from a detached academic exercise into an engaged practice with ethical dimensions. If consciousness plays a role in cosmic cycles, if aware beings can influence how information transfers between cycles, then our choices and actions matter beyond their immediate effects. They potentially shape how consciousness manifests across eternal cosmic time. This doesn't mean we control cosmic destiny or bear responsibility for universal evolution. Our influence remains limited by our scale, duration, and understanding. But it does suggest that our development of knowledge, our cultivation of awareness, our creation of meaning aren't merely local phenomena, but contributions to an ongoing, cosmic process extended across infinite cycles. In this light, the quest to understand whether the universe cycles eternally becomes more than theoretical curiosity. It represents one expression of the universe seeking self-knowledge through conscious structures complex enough to model their own origins and destiny. Our cosmological theories, whether they ultimately prove accurate in all details, contribute to reality becoming increasingly self-aware through us. As we conclude this exploration, we return to our opening question. Could the universe be a idle loop with no end? The evidence remains suggestive, but inconclusive. Various theoretical frameworks, loop quantum cosmology, conformal cyclic cosmology, brain-world scenarios, offer mathematical models for how the cosmos might cycle eternally. Observational data from the cosmic microwave background, from gravitational waves, from large-scale cosmic structures, provide hints but no definitive confirmation. Yet the very fact that we can pose this question, that conscious beings have evolved, capable of contemplating cosmic cycles spanning timescales far beyond individual lifetimes, represents something remarkable. We are the universe reflecting on its own possible cyclicity, matter and energy organized into patterns complex enough to model the larger systems they comprise. This self-referential quality doesn't prove that the universe cycles eternally, but it does suggest that consciousness represents an integral feature of cosmic evolution, rather than an accidental byproduct. In a universe complex enough to produce beings who can contemplate eternal cosmic cycles, awareness becomes not an anomaly, but a natural expression of underlying patterns that potentially repeat across infinite time. So where does this leave us? With uncertainty, yes, but uncertainty informed by sophisticated mathematics, by careful observation, by theoretical frameworks that integrate multiple perspectives while acknowledging their provisional nature. With questions that extend beyond what we can currently answer, but that orientation to a deeper understanding of our cosmic context. And perhaps most importantly, with a transformed sense of who and what we are in relation to the cosmos that produced us. Not accidental byproducts of blind physical processes, not special creations standing apart from the rest of existence, but conscious expressions of a universe potentially cycling through eternal iterations of death and rebirth. Temporary configurations that embody and express patterns spanning infinite cosmic time. This perspective doesn't eliminate the mystery of existence, but deepens it. It doesn't provide final answers, but more profound questions. It doesn't resolve the paradoxes of consciousness and cosmos, but integrates them into a framework that acknowledges both our transience as individual beings and our participation in potentially eternal cosmic patterns. And this brings us to a final question, perhaps the most unsettling of all. What if we've been asking the wrong question from the beginning? What if the universe doesn't cycle as an object separate from us, but as a reality that includes us? What if cosmic recurrence isn't something that happens to the universe, but something that happens through it, and through us as conscious configurations of cosmic elements? If consciousness plays a role in cosmic cycles, if aware beings influence how information transfers between iterations, then we aren't merely observers of universal patterns but participants in them. Our understanding of cosmic cycles would be not just a description of external processes, but a development within those processes, the universe using specific conscious nodes to model its own cyclical nature. This participatory understanding transforms both what we know and how we know it. It suggests that consciousness isn't just another object of study, but an integral aspect of the knowing process itself. Not something separate from cosmic cycles, but one expression of how they operate. In this light, the question changes from, does the universe cycle eternally? To, how does reality, including consciousness, pattern itself across cosmic scales? From, what is the fate of the universe? To, what role does awareness play in cosmic evolution? These questions don't have simple answers, but open new frontiers of exploration, not just empirical investigation of physical processes, but deeper understanding of how consciousness participates in and potentially influences those processes. They invite us to consider not just what we know about the cosmos, but how we know it. How the knowing process itself represents one expression of cosmic patterns, potentially repeating across eternal time. As we gaze outward at distant galaxies and inward at our own awareness, we participate in a singular cosmic moment, a brief window in universal evolution when conscious beings have emerged capable of reconstructing cosmic history, of modeling potential futures, of contemplating eternal cycles that may have occurred before and may occur again infinite times. Our existence in this particular cosmic moment isn't merely coincidental. The anthropic principle reminds us that we could only exist during the era when conditions allow our form of consciousness. Yet the fact that the universe has produced beings who can contemplate its cyclical nature suggests something profound about reality itself, that it naturally develops self-awareness under certain conditions of complexity and organization. If the universe cycles eternally, then consciousness like ours has likely emerged before and will emerge again across infinite cosmic iterations, not identical to our current expression. Quantum variation ensures differences, but similar in its capacity for self-reflection, for cosmic modeling, for contemplating its own origins and destiny. This perspective transforms our brief lives, from cosmic accidents to natural expressions of eternal patterns, temporary configurations that embody and express an underlying reality, cycling through infinite iterations of death and rebirth. We are not merely in the universe, we are of it, conscious embodiments of cosmic processes that potentially repeat across eternal time. And so, as our exploration concludes, I leave you with one final thought. A possibility that emerges from everything we've discussed, yet extends beyond what we can currently confirm. What if the universe cycles not just physically, but consciously? What if awareness itself, the subjectivity reading these words, contemplating cosmic cycles, wondering about eternal recurrence, represents one expression of patterns that repeat across infinite cosmic time? This wouldn't mean your specific personality, memories, or thought patterns recur identically. Quantum indeterminism ensures variation in each iteration, but it would mean that the fundamental capacity for experience, the basic awareness that manifests in different forms throughout the cosmos, persists through cycles of universal death and rebirth, taking new configurations while maintaining underlying continuity. If consciousness is fundamental rather than emergent, if awareness represents not a strange anomaly, but an integral aspect of physical reality, then it wouldn't be extinguished by cosmic death, but would transform along with matter and energy, persisting through the transition between cycles in forms we currently cannot imagine. In this light, your existence reading these words represents not merely a temporary accident soon to dissolve without trace, but one expression of patterns that cycle eternally, one manifestation of the universe becoming aware of itself before reconfiguring into new forms across infinite cosmic time. This doesn't promise personal immortality in any conventional sense. Your specific configuration, the particular pattern you identify as yourself, will indeed dissolve with death. But the awareness experiencing reality through your perspective may represent one expression of something that persists through cosmic cycles in different forms, taking new configurations while maintaining underlying continuity. Various contemplative traditions report that deep meditation can temporarily dissolve the boundaries of the separate self, revealing this continuity beneath apparent separation. These experiences suggest that consciousness may be more fundamental and less localized than our everyday perception indicates, more like a field with various focal points than a collection of isolated individual minds. In a cyclical cosmos, this field of awareness wouldn't be extinguished by universal death, but would transform along with matter and energy, persisting through the transition between cycles as an integral aspect of physical reality. Individual focal points, specific conscious beings, would dissolve and reconfigure, but the fundamental capacity for experience would continue in new forms. This perspective doesn't eliminate the mystery of consciousness, but places it within a cosmic context that acknowledges both its transience in specific forms and its potential continuity across eternal cycles. It suggests that awareness isn't something separate from physical reality, but an integral aspect of how the universe patterns itself across scales from quantum to cosmic. As you ponder these possibilities, you participate in a process that may have occurred before and may occur again across infinite cosmic time. Conscious matter contemplating its own cyclical nature, the universe reflecting on eternal patterns that potentially include consciousness, itself as one expressing form. This self-referential quality doesn't prove that the universe cycles eternally, but it does suggest that consciousness represents not an anomaly, but a natural feature of a cosmos potentially cycling through infinite iterations of creation and dissolution. In a universe complex enough to contemplate its own cyclical nature, awareness becomes not accidental, but integral to cosmic patterns. And so, I leave you with this question, not as a conclusion, but as an opening to further exploration. If the ET universe cycles eternally, what role does consciousness play in those cycles? Are we merely passive observers of cosmic patterns, or do aware beings influence how information transfers between iterations? Does the universe merely repeat physical configurations, or does it learn and develop across eternal time with consciousness, playing an increasingly central role in cosmic evolution? These questions extend beyond what current science can definitively answer, but they emerge naturally from what our best theories suggest. They invite us to consider not just what we know about the cosmos, but how we know it, how the knowing process itself represents one expression of patterns potentially cycling across eternal time. As you gaze at the stars tonight, consider this possibility. Your awareness doesn't just perceive the cosmos, but participates in it. Your consciousness isn't merely produced by physical processes, but represents one way those processes experience themselves from within. You are not just in the universe. You are the universe in one of its conscious configurations, a temporary pattern that may dissolve but embodies forms potentially recurring across infinite cosmic cycles. The universe may loop eternally, cycling through endless iterations of expansion and contraction, complexity and simplicity, death and rebirth, and consciousness. Awareness itself may represent not an accident, but an integral feature of those cycles, taking different forms but maintaining continuity across eternal cosmic time. In this light, your existence becomes simultaneously fleeting and eternal, a temporary configuration expressing patterns that potentially repeat across infinite iterations. You are both a wave soon to dissolve back into the cosmic ocean and an eternal expression of that ocean's inherent nature. Simultaneously, transient and timeless, finite and infinite, ephemeral and eternal. And perhaps that is the most profound possibility of all, that in a universe potentially cycling through eternal iterations, nothing is truly created or destroyed, but merely transforms from one configuration to another across infinite time. Not just matter and energy, but consciousness itself. The awareness reading these words, contemplating cosmic cycles, wondering about your place in an eternal universe. The cosmos may have no beginning and no end, just infinite transformations of the same underlying reality. And you, in your brief conscious moment, represent one expression of that eternal pattern, one way the universe knows itself before dissolving and reconfiguring across infinite cosmic time. The universe may be a loop with no end, and in the deepest sense, neither are you.